individual efforts among this community at the university level, perhaps, who want to set up and sustain their HPC. Whereas before, perhaps our outlook was for our core to absorb all these compute requirements and demand, but frankly, that might not be possible in terms of scaling this up and serving everybody. And besides, we are an archipelago. We have to redistribute resources and wealth and the population to the other 7,000 islands and not concentrate them here in Metro Manila and Luzon. Right? I think that's one way to solve traffic. Right? Okay, so the strategy towards federation may be a better option, since we are in effect trying to consolidate HPC resources. This is being done in other countries, as you know, US, Japan, Europe, etc. Okay, so the critical points, if we push for this, would be readiness of compute facilities for federation. It's not just technical readiness, it's a mindset, it's a philosophy, it's a practice, right? And ASTI has initiated the National HPC Research Computing Shared Resources Readiness Survey. So some of you might have already filled up this survey, some of you probably not yet, but we are using this instrument to get your inputs towards this, achieving this initiative of consolidation, well, federation. Okay, so the survey is quite comprehensive. Jen gave me some notes here. I'm not going to read all of them, but it has 9 sections. No? Maybe a grand total of like almost 100 questions in the survey. Okay, of course, apart from your contact organization details, your HPC Research Computing Center profile, technical characteristics of your HPC or the desired characteristics of your HPC or your university computing center, the software and application domain requirements for that HPC, the staff and support services that you have or need, which is very important, the training components, policy and governance for local HPC resource sharing, and human resource and communication strategy. Actually, the survey is rather biased in terms of question towards the technical side, but it also addresses things like important considerations like the staff support and training and the policy and governance policies. Okay, so the message really, for not only for that survey, but for today's event, is we need everybody's cooperation in making this federation, this larger, I guess, conglomerated facility that can cater and be more responsive to everybody's computing requirements. We need everybody's cooperation, because another critical issue here is the willingness of those who have these HPCs or those who have plans to set up their own HPCs to essentially, I guess, build a shared infrastructure. So that's something that I think our community should work towards, and by this gathering today, I think it's a very promising start. Maybe it's already started. This is just one event where we're all together in one room, and that's the message for today. And I really hope everybody contributes, and we can get what we want out of this meeting and move forward positively and constructively. So in ending, maybe I just acknowledge the team here who organized this event and our host, the UP Computer Center. This is the first time I've been back here in this room. I don't remember it looking this nice before. So kudos to the UP Computer. So si Dennis, batawa kasi, I don't know, memories mo dito, no? Okay? Baka nightmares, no? Yung mga nagpa-punch cards pa dito, hindi ko alam. Hindi ko na inabot yun, no? But mga PC era na kami. But yeah, it looks nice, and you know, we have a good view of the sky there, and the sundial behind you, which is already probably not working anymore because it's being shadowed by the buildings. But that used to work, no? That sundial there. It's a symbol of the College of Engineering here, which is right over there. So again, welcome, and thank you very much. Good morning.
Thank you, Doc Joel. Okay, yes, Doc Joel mentioned about the facility. First of all, we'd like to thank UPCC for accommodating us. Actually, this is, I think, this Dr. Ramos, most especially the head of UPCC. This is actually the second time in a month ata that they accommodated us to use the facility. And actually, this is a very modern facility. In fact, you can access the Wi-Fi. If you need the Wi-Fi, just choose the core. And then the Wi-Fi password is ASTI, ASTI in small caps, 100, and then big letter G, BPS. So it's ASTI 100 GBPS. Okay. So to continue on with our program, Dr. Marciano succinctly summarized what the expected discussion is for this morning. So later on about the survey, some of you are familiar with the survey and some of you have already answered the survey. I'll discuss it more in detail. Okay, so the purpose really of that survey, as the theme we have this morning, is towards a shared infrastructure for HPC that we want to push locally, because in the international scene, all of these federation in terms of HPC, in terms of cloud, is already happening, and these are actually the focus of our presentations this morning. So most of our presentations are remote. As much as we would love to have our speakers come here, of course, the time and the resources we are unable to bring them here, but we are very, very honored that they were able to, accommodate us to at least give a remote presentation. And maybe in future gatherings like this one, because this is the first joint, so definitely we'll have succeeding joint Preginet and COARE stakeholders meeting. Maybe in those future conferences, we would be able to invite them here to give a live presentation. Okay, so for the meantime, we proceed with the program. Our next speaker, sorry, I need to wear my glasses. So currently, he is the Undersecretary of the Department of Information and Communications Technology. Sir Dennis campaigns for a smarter government, and that, I think, is the primary reason why he took on the helm of formerly ICTO when it was still with under the DOST, and now it's DICT, back in 2011. Okay, so the programs he has spearheaded have always emphasized the role of ICT in engagement and collaboration to achieve efficient, transparent, and accountable governance for the benefit of the Filipino. So for more than a decade, he served as the director of ASTI, and that led to the conceptualization and contributed to the design and implementation of various innovative and flagship programs such as Preginet, COARE, of course, Philippine Open IX, Project NOAA, ASTI also has a part in that, and then the Integrated Government Philippines, the National Broadband Plan, and the National Government Portal, and the Public Wi-Fi Project, and these are still being implemented by DICT right now. So in his almost 30 years of government service, he received a number of commendations, among them the 2010 Gawad Career Executive Service. And right now, as Undersecretary for the National ICT Assets Index, he is heading the consolidation of both public and private ICT assets. And his presence here is critical because that will feed all of our discussions here, especially in terms of the infrastructure and the ICT assets that we have in our institutions, will feed into the objectives and outputs of his role as USEC of NICTAI. So I'd like to welcome Sir Dennis.
Thank you, Jang, and good morning. So I'm actually very conscious of the time because we have four speakers who are doing a remote presentation, and I note that we're a few minutes behind, no? But thank you for the introduction. So I'm very happy to be here. It's been a while since I've been in a meeting of this community, since 2016 when I left the OST full-time sa DICT. And been very busy there. Now have more time. So happy to be here and glad to see this growing community. You're all here because you are stakeholders, no, for this what we call shared national science data infrastructure. And whether you're part of building it or you're a user of this infrastructure, or you're a funder, or like in my case, siguro cheerleader na lang. You have a stake in this, and so it's important, and that you are here and you get updated on the developments. And this is actually siguro not the case a number of years back. We had different challenges then. So, for example, I recall, we were trying to link up with this Global Science Initiative, and I had this conversation with a professor, and I was quite discouraged because from his perspective, he didn't want really to collaborate with counterparts abroad, and this was his reason. So we have our own data, and because we might get overtaken, or if we collaborate, then our collaborators might come out quicker with papers, no, or output. And so from his perspective, he didn't really want to link up, but we were trying to encourage him because we thought that would allow more significant work, or bring him access to more data, or encourage his students or researchers, because we wanted to develop the community here. So the other was, and many of you know this, no? Last Friday, Secretary Boy mentioned that the DOST before, pag nagsispeech daw yung mga secretaries, always emphasized kung ano yung kulang. Lack of instruments, lack of data. And many of you will agree, in many ways, that has been addressed already by our government, by you, the community, no? And so we have so much data, right? Some of you here have been involved with Project NOMA. Ni ba? Or si BA nandyan. Before, di ba, we had a large remote sensing community, and they were doing a lot of good work, but it ended up just in papers, publications. And we were looking to how do we operationalize this, because our people need it. And algorithms, the methodologies, would provide really good science-based, evidence-based information and knowledge that we need. But the problem then was, where do we get the data? And now we have our own satellites, plural, not just one, di ba? And we have access to many more that are owned by other countries. And we have the capability to directly receive this data. So, mas ang problema, di ba, is how do we process, what do we do with this data, right? How do we extract information that's relevant to you as end users, rather than just having, the data to deal with. We have a lot of instruments that are able to provide us data, environmental data, agromet. Within the DOST, I think in the last few, I'm not sure if it's being continued, but they've deployed, thousands of sensors, and I hope that's continuing to provide good data that is made available to end users. And And so in many ways, you know, yung challenges before, this is no longer the case. And so for example, we have our own, I think, sequencers, right? Before, we could only try to link up with the, you know, genomic databases abroad so that they could be made available to the, you know, bioinformatics community here. But now we have, you know, this equipment here. And then you have all of the data that's on the internet, of course. And, you know, so iba na yung challenges, right? And from my perspective, I think what we need is to strengthen. We need to scale and expand the infrastructure that we will need so that what we have can become more inclusive. So not just here in Metro Manila or in our Tier 1 cities, but also those scientists, those researchers that are, you know, in our regional, well, the state universities and colleges, and so on. We need to train and educate more people so that, you know, this data can be made useful, no? I think rather than data or where to get it, ang challenge natin is how do we process it, right? And then sustain this. So what you are trying to do here is very significant in that context, that we need to become more inclusive, and we need to scale, and we need to sustain this. On the part of the DICT, well, Jeng mentioned it, that I have been tasked to create an index of ICT assets, not just within government, but to include ICT assets of the private sector, more specifically halimbawa for connectivity, because that's, I believe, something that we all recognize as something that needs to be improved further, you know. And the ICT, with Secretary Honasan there, has focused on just two things. One is how to improve connectivity within the country, with the Philippines, with other countries. And second is how to leverage technology to make government more efficient, right? And provide efficient public services to our citizens. So this is where I think we can collaborate. A lot of the things that I was exposed to while I was with the OST, I have tried to bring to the DICT, and vice versa, right? Within the DICT, if you are looking at building, let's say, HPCs within your facilities, right? That would be good, so that you can gain access and capability. But I would maybe challenge the notion that you can do it alone, or that you stop there, right? I think there will be a need, and that's I think the role of the OST with ASTI there, to build nationally significant science data infrastructure that is available to the community. So it's a complement, no? So may national facility and then may local facilities. But then you need the connectivity there to link them up. Both for you know, providing computing resources or storage resources or the data and access to data wherever they may be, right? So it's both to connect facilities here in the Philippines as well as our facilities with facilities abroad. And so this initiative to strengthen collaboration and connectivity is very significant. And then the human resources to back that up. so that we come up with really significant output that hopefully can be translated to things that matter to our people, no? That will improve their lives. So within the DICT, dati we were only dreaming yung mga gigabit capacity na links. I think when we started, we had kbps level capacity. And we were very happy when we upgraded, siguro 25 years ago naman na to. When we got our upgrade to a multi-Mbps, siguro 4 Mbps na connectivity. Now, we are working towards multi-100 gigabit connectivity. And that includes yung domestic links natin. And we need the output of all of your work, including the people that you are training, to make this happen and to make this sustainable. So we need to complement what this community is doing and creating. Finally, I want to encourage you to be involved, to contribute, get your colleagues involved as well. Discover collaborators, and all of these events are there for that, so that ultimately we do good and significant science and develop our next generation of Filipino scientists, researchers, and educators. So again, marami pong salamat for inviting me. I hope you continue to invite me to your events, and thank you so much, and mabuhay.
Thank you, Sir Dennis.
Thank you, Sir Dennis.
Thank you, Sir Dennis. Actually, yeah, Sir Dennis holds the history of how we really started, and he's correct. We started with, when I came to ASTI back in 2003, it was 256 kbps, and right now we're at the 100 gbps already. So there are a lot of developments also in terms of the community, and that's what we're pushing through in our stakeholder meeting this morning. So I'd like to pass on to my colleague Charmaine. By the way, I'm Jeng. And
Charmaine, hello. So we also would like to announce that we have live streaming up. You can check the link po sa Facebook page ng COARE and ng PREGINET. So if you have colleagues who are not here with us, who are not presently here, and you would like them to also participate in this event, you can just share to them the link for our live stream. So we also would like to announce that we are implementing EduRoam Wi-Fi here in UP, and we hope that all institutions in this room will also enable EduRoam in their institutions. So let's move forward. Our keynote speaker is an associate professor of the Department of Biochemistry of the National University of Singapore. He is an internet pioneer in Singapore who founded the multilingual internet domain name system and has been instrumental in its internationalization. He is also responsible for spearheading research on the converging interface between life sciences and internet technologies. He has been widely recognized for his award-winning technological efforts in the Tamil-speaking community. Dr. Tan was responsible for several major internet milestones in Japan, including the first Gopher server, Singapore InfoWeb, and the forerunner of the present National Web homepage, InfoMap, FirstWise, and Gopher server in Japan, or the RICAN, the first internet cybercast of Singapore's National Day Parade, and many other events since 1994. During his leadership of the Internet Research and Development Unit, Singapore became the first regional Java website, VRML website, 6-node, ActiveX website, and the world's first operational multilingual domain name system. He is also an inductee at the Internet Hall of Fame, a recognition program and virtual museum that celebrates the living history of the Internet and the individuals whose extraordinary contributions have made the Internet, its worldwide availability and use, and its transformative nature possible. To deliver his keynote message for today's COARE PREGINET stakeholders meeting, please welcome Dr. Tan Kin Wee.
Good morning. Thank you very much for inviting Deputy Minister Dennis Villorante, Undersecretary of the DICT, Director Dr. Joel Marciano, Chief SRS Research Division Peter Banzon, leadership of ASTI, COARE, PREGINET, dignitaries, VIPs, colleagues, and friends, ladies and gentlemen. Thank you for the very kind introduction and for the invitation to give this keynote address on towards a shared infrastructure for research and education at this inaugural stakeholders meeting. It is indeed an honor and a privilege for me. As Chief Executive of Singapore's National Supercomputing Center, NSCC, and the founding principal investigator of Singapore's Advanced Research Education Network, SINGAREN, as well as ASEAN Focal Point for Singapore in the Subcommittee for Infrastructure Research Development, SCIRT, of ASEAN Committee on Science, Technology and Innovation, COSTI. Let me begin by sharing my experience and the experiences Singapore has gone through over the decades in this arena of shared resources for the advancement of research and education. As a tiny island city-state, Singapore has made significant strides forward for our people in becoming such a wonderful place to be in. We have worked hard and achieved much in the past half century or so. Our economy is improving, albeit at a slower pace, but still driven by hard work, cooperation, and technological progress in particular. This amazing driver of our success has been our embrace of new technologies, especially in the process of digital transformation of Singapore's research, education, and industry sectors. Whether it was the internet over the past 25 years or now high-performance computing for boosting anything from big data analytics, artificial intelligence, industrial Internet of Things, Industrial Revolution 4.0, advanced manufacturing, 3D printing, or soon perhaps even Society 5.0, quantum technologies, and so on. We have worked hard to ensure the benefits of technology reaches the masses. For supercomputing or high-performance computing, or HPC as we call it, we have tried to extend its access to our researchers, scientists, professors, and students in at least 4 vertical domains of AME, Advanced Manufacturing and Engineering, HBMS, Health and Biomedical Sciences, SDE, Services and Digital Economy, and last but not least, USS, Urban Solutions and Sustainability. All these come under our National Research Master Plan, RIE 2020. Last year, at our AI conference coordinated by AI Singapore, our HPC AI platform was set up to support our Smart Nation platforms. This year, at our Supercomputing Asia 2019 conference in March, our government has announced 200 million worth, that's about 150 million US dollars, dedicated towards supercomputing. In this picture at the top, you will see, peeping into the future of computing through this model of a quantum computer exhibited at this conference, you can see our newly installed Deputy Prime Minister Heng Swee Keat backing the growth of supercomputing in Singapore. Bulk of these current fundings allocated will be channeled towards the National Supercomputing Center, NSCC, to build the future generation of advanced computing facilities as part of our National Research Infrastructure, NRI, of the National Research Foundation under Prime Minister's Office. This funding will be a great boost to the existing petascale facility which we have built and maintained over the last 5 years. It will help us digitally transform all research domains, promote a computationally savvy and well-educated workforce, as well as link us through advanced networking to far better endowed supercomputing centers worldwide for us to learn and to tap their expertise. It will help us and provide us with the resources to support our participation and leadership in international organizations such as the Asia Pacific Research Platform, APRP, launched a couple of years ago, as well as the nascent Global Research Platform, GRP. In fact, as we speak, top leaders are gathering in Denver, USA in a BOF session at the Supercomputing SC19 conference to discuss how to create the Global Research Platform. It was only a few years ago that we spent a lot of effort gathering the cooperation of founding members to build NSCC's first supercomputer, the first petascale supercomputer in this region, codenamed Aspire-1, Advanced Supercomputer for Petascale Innovation, Research and Enterprise, built in 2015 through the cooperation of founding members, ASTAR, the Agency for Science, Technology and Research, NUS, National University of Singapore, NTU, Nanyang Technological University, and SUTD, or Singapore University for Technology and Design, sharing resources in order to get funding from the government. We have managed to unveil this machine, spending a year since 2015 to build it. After 3 to 4 years of this system's operation, it will be expanded. In the next phase, starting 1st October 2019, 6 weeks ago, for another 5 years until 2024, we will be expanding on phase 1 and moving into phase 2 of our HPC efforts. Concurrently, may I also add that our Singaren network counterpart to PREGINET in the Philippines will also be boosted with new funding. Together in cooperation and sharing of our resources and technological capabilities, NSCC and Singaren will be working towards expanding the current utilization of NSCC's resources in order to support Singapore's R&D initiatives, attract industrial collaboration and research, enhance Singapore's research capabilities. In this slide, you will see in the past 3 to 4 years how this machine has been heavily utilized. These numbers will continue to increase in phase 2 as the pie will be enlarged at least 10 times over the next 5 years with the generous funding that the government has allocated to us. The ease of last mile connectivity will be enhanced and will continue to improve. Last mile problems will be addressed to reduce any friction which our researchers might have, whether it is a researcher in a hospital, a DNA sequencing farm, or an advanced manufacturing factory of the future, experimenting with new designs and models digitally. Our connections will reach all universities, polytechnics, government research labs, and hopefully to our schools, and also, our last but not least, to our industries. Singapore is not yet at cutting edge of HPC or supercomputing, as you well know. All the top HPC nations are racing towards exascale computing, while we were just a new entrant to the petascale computing era. Singapore will continue to improve our mastery of petascale computing, even as we move forward to phase 2 of NSCC. To this end, we really need to learn from our international friends and colleagues, not just from ASEAN, especially from Philippines, but also from those advanced nations in USA, in Europe, Japan, China, and Australia, who are already very advanced in their leadership of computing in transformation of their science and technology, research and education and innovation arenas. Through strategic partnerships in connecting with high-speed links, 100G and above, each of them, we hope to accelerate our learning process and leverage on research opportunities to carve a niche for ourselves maybe a small one in this rapidly advancing space. This is how we have benefited from a nationally shared platform in our effort to shorten the time to scale our resources to support our researchers. We hope that we can now partner our ASEAN neighbors through an initiative called ASEAN HPC to scale these benefits to others as well. This month, an invitation for ASEAN delegates to visit Luxembourg and Barcelona to discuss with the European Commission and its funded supercomputing centers on how we can achieve this. Led by Thailand and Singapore, these key opinion leaders of our countries will learn from these visits how we can leverage on the experience of Europe to help build our own infrastructure in a shared, cooperative manner. If we can do so effectively, we can even play a key role in participating and possibly even driving the development of the GRP in our region, not just as a bystander passively absorbing new technology, but as an active builder in shaping the GRP to meet the aspirations and needs of our people. This cooperation with friends in Asia, Europe, and America, and maybe even beyond, will bind us together as scientists, researchers, and educators in an increasingly divided and fractious world. It will help us identify common goals and work together to solve global problems, not least the effects of global warming and climate change. In a data-intensive world, it will help us to bridge digital divides between the information haves and have-nots. Such a shared global infrastructure for research and education will bridge gaps amongst the most developed nations with the developing ones. Our Global Data Mover Challenge, for example, the DMC, which we have organized, has been addressing how big data can seamlessly flow and be disseminated across the globe to reduce this gap between data haves and data have-nots. This is an example of how we can advance the cooperative efforts amongst our different nations. Moving forward, as of 1st October 2019, I now have the resources from government and our taxpayers to make this happen. The future of supercomputing in Singapore NSCC 2.0 from 2019 to 2024. Our significant amount of funding should be able to help us propel ourselves well into the petascale league and perhaps even position ourselves in the next 5 to 10 years to even reach the exascale. Will you now join me in making this happen for us and for our region and for the world? To build strong bilateral and multilateral ties in ASEAN in Asia, to identify international and regional projects of mutual strategic importance, open up our resources, provide seamless connectivities for research, for education, innovation, enterprise amongst our peoples, and to promote research collaboration and uplift each other's capabilities and capacities so as to enhance science, technology, and innovation in our midst. We have already been doing this for a long time. My friend Dennis Villaranto will testify and has already testified, and in fact he is the living embodiment of this effort of cooperation and sharing of resources from the days of the advanced Asia-Pacific Advanced Network, APAN, eBionet, and many others. This cooperation can and should continue into the future. For this to happen, we need to meet more often, and perhaps may I invite all of you to meet with us and many, many others from the rest of the world at the Supercomputing Asia Conference starting 24th of February 2020. SCA 2020 will feature high-performance computing, powering intelligent cities. It will feature Industry 4.0 as well as Society 5.0. There will be hopefully a special track on the HPC have-nots, especially those in computational humanities. Aside from the traditional HPC topics of modeling, simulation, AI, quantum computing, quantum networking, I hope that I will see many of you at this conference, and welcome to Singapore. And thank you very much for inviting me to address this keynote and seminal inaugural event of the stakeholders meeting of COARE and PREGINET. Thank you, and have a great conference.
Okay. Thank you very much, Dr. Tan Tin Wee. Maybe if you don't mind, we can have just one question. Is it okay, Dr. Tan?
Of course.
Yes. Is there a question for Dr. Tan Tin Wee? Okay, so if there's no question, Dr. Tan Tin Wee, thank you for your presentation, for your keynote. That certainly is a very impressive work being done by the NSCC. As we all know, SG leads the ASEAN in the ASEAN region in terms of network and research computing, as what we have seen from Dr. Tan Tin Wee's presentation. And from these, we have a lot to learn from what Singapore is doing in terms of the network and the research infrastructure that are available for our local research community. So through initiatives such as the ASEAN HPC Task Force, of which Dr. Tan Tin Wee is the key opinion leader for Singapore, we are also benefiting from SG's experience. So as the takeaway, I guess, for me, for Dr. Tan Tin Wee's message is that government support is really vital in building these research infrastructures. And well, we know that Singapore government is very supportive of the research community. And from Dr. Tan Tin Wee's presentation, we see the level of investment that the Singapore government is really putting into the scientific research. So I would like to hopefully locally we can also get that much support, and we are actually getting that much support right now from our government. So again, Dr. Tan Tin Wee, thank you for accommodating us and giving the keynote for our stakeholder meeting. And we hope to see you, I guess, Sir Peter and Bani will be seeing you in succeeding meetings for the ASEAN HPC Task Force. So thank you very much. Okay. So I'd like to call on Charmaine to introduce our next speaker.
Our first presenter has over 15 years of experience in network architecture, design, engineering, performance, and security in scientific and research environments. He is currently a network engineer in the ESNet Science Engagement Group. He coined the term Science Demilitarized Zone, or the Science DMZ, and is an advocate for the Science DMZ design pattern and works with facilities, laboratories, universities, science collaborations, and science programs to deploy data-intensive science infrastructure based on the Science DMZ model. Mr. Eli also runs the ESNet Network Requirements Program, which collects, synthesizes, and aggregates the networking needs of the science programs ESNet serves. As a member of ESNet's Network Engineering Group, Mr. Eli was a primary contributor to the design and deployment of 2 iterations of the ESNet backbone network, ESNet 4 and ESNet 5. To present on deploying science infrastructures based on the Science DMZ, please welcome Mr. Eli Dart.
Yeah, can you hear us, Eli? Okay.
Okay. So, hello everyone, and thank you very much for the opportunity to present to you today. I'm going to give a talk about the science DMZ model. Let's see, should I share my screen, or do you want to drive the slides from there? Let's see, if I share this,
Slides from here. Okay.
Is that okay? If you're going to drive the slides from there, that's fine. Let's talk a little bit about why we do the science DMZ. There are several things that are important for data-intensive science, right? And we've heard some of them in the keynote. Dr. Tantin, we mentioned networking. I'm going to talk a little bit more about networking in support of science. So I would say that networks are an essential part of data-intensive science. They connect the different parts of the science ecosystem together with each other. They provide access to data. They allow machines to talk to each other. But as data sets grow, performance is actually really critical. In the environment that we live in, all of us together, data growth is exponential. And I don't know about you, but I am not an exponential person, right? I can't scale exponentially. And so what we really need are tools and architectures that allow us to scale the science that we can do with data without having to scale the human effort required to manage that data. And so a big part of doing that then is moving the data from wherever it is to wherever it needs to be. That involves networks. Unfortunately, it's historically been hard for scientists to use long-haul networks for this. So that's the sort of setting for this. And then on slide 3, if we look at, there's a couple of examples here of what we can do when we get this stuff right. So this describes the first exascale science application. It was run on the Summit machine at Oak Ridge National Laboratory, and it's computational biology. It's a genomics data analysis application. And if we go to slide 4, there's another example of using machine learning to identify atmospheric rivers in climate model output. Again, this is many terabytes of data are used in these sorts of simulations. So on slide 5, science groups like this can use essentially all the data that they can get their hands on. And in many cases, what they really need is all the data in a field that meets a given set of criteria, and they want to put all that into a big machine and run some sort of advanced data analysis on it. And in order to do this, right, they need to be able to get their hands on the data, right? This only works if the scientists can get the data from wherever it is. Maybe it's in a bunch of different locations. In many cases, it's distributed throughout the world. They can get the data to the machine at scale. And the science DMZ model provides a way to move that data by architecting the network effectively. So on slide 6, this is an example of when things work well, right, when we get things configured correctly. So this is the results of some work that we did at 3 supercomputer centers at DOE National Laboratories and also the National Center for Supercomputing Applications in Illinois. What you see here are the results of their minimum, average, and maximum, blue, black, and red, of 3 transfers in a given direction. And the composition of the reference data set is there in the lower right. I apologize for the small text. It's about 19,000 files, about 200 directories. It's about 4.4 terabytes in size, and the file size ranges from 0 to about 11 gigabytes. 0 bytes to about 11 gigabytes. And the size distribution is in the column below that. So this is not a benchmark-friendly data set at all, right? This is real simulation output that I got from a cosmology group. And this is an example of the kind of data set that scientists need to transfer. So if things work well, right, if things are set up correctly, they can move this kind of data set in a few minutes. right, which is great. And so, okay, how do we do that, right? So if we look at slide 7, the strategic context for the science DMZ model is we have these big fast networks. We're talking about getting 100 gigabits to all parts of the world. You have your own 100 gigabit circuits up. That's great. The ESNet backbone is currently composed of 100 gig circuits. This is really, really powerful. And we need to connect all of those computing centers, but also the experiments, also the data portals, and the universities and laboratories themselves, all to these fast networks. And in order to have those networks work effectively, there's some specific engineering that we need to do. And the science DMZ model describes that specific engineering. So looking at slide 8, we've been talking about sort of the central role of the network, right? The very structure of modern science assumes that there's a high-performance, feature-rich network interconnecting all parts of a science collaboration. So we think about what is this thing, right? What is this, the network thing? It's not just the routers and switches and optical circuits and things like that, right? It's all the set of devices and applications involved in using a remote resource. So that means networking is end-to-end, right? All the different pieces are involved in this. Data transfer servers, the applications themselves, right? The file systems, all those things. We have to think about all of those things as part of this one integrated whole that is a network. Right, so that means that everything from the network core out through the end systems, through the applications, has to be architected well and configured well. So slide 9, I like to say that, so we're stuck with TCP for this, right? The TCP is mostly how we do this. We think about how applications running on hosts see the network, right? Their interface to the other end of the connection is a socket, right? And communication between the ends is over typically TCP on that socket. And so in order to effectively run that at high performance, then we need high performance TCP. Well, TCP I like to call the fragile resource, or the fragile workhorse, because it interprets packet loss as congestion, and over long distances that badly impacts performance. And in fact, in most cases, we're stuck with TCP, right? TCP is something like 95% of ESNet traffic, right? It's the protocol that we use to carry data reliably. If you look at slide 10, this illustrates just how bad it is, right? So the impact of packet loss on TCP performance is so great that the text describing how bad it is fits between the happy purple line at the top and all the other sad lines at the bottom in the path or in the plot. So so this is a set of tests that were run on the ESNet backbone. The purple line is what happens with no packet loss. The y-axis there is throughput in megabits per second from 0 to 10 gigabits. And the x-axis is the round-trip time in milliseconds between the communicating hosts. And so you can see that beyond sort of metro area latencies, right? Once you get up above up to about 10 milliseconds and higher, if you have any packet loss at all, performance is really bad. I mean, look at the packet loss rate that's there, right? That's about 1 packet in 22,000. It's tiny, tiny, tiny amounts of packet loss, and this has this huge impact on performance, which means we have to engineer the entire end-to-end path so that TCP does not see any packet loss. So going to slide 11, if we're going to put a solution together for this, what do we actually need, right? We need to support TCP. It has to be easy to adopt because networks are large and complex. And nobody's going to go re-architect their entire network just to try something out. In terms of security, we have to be able to defend it without causing performance problems. And I'm going to talk more about security in a moment. So if we put all this stuff together, we borrow some ideas from traditional network security, right? Traditionally, in network security, we have this idea of a demilitarized zone, or a DMZ. That's a special part of the network where external-facing services are hosted and configured. It's often on separate hardware. It has separate policy governing it, and is deployed for a specific purpose, which is to talk to things out in the rest of the internet that are a long distance away. So we think about the same idea, and we say, okay, we're going to put together an enclave for all the high-performance data-intensive science assets. We can call that a science DMZ. Looking at slide 12, right, there are several interlocking synergistic components of the science DMZ design pattern. So go to 13. We break those out. We have in the center here, we have the network enclave itself, right, the architectural element. It's a dedicated portion of the network at or near the site perimeter that is specifically designed and dedicated for high-performance data resources. It's got appropriate security, right, and it's easy to add on to the existing network. On the left-hand side, living in that science DMZ are dedicated systems for data transfer. These are typically called data transfer nodes. They're high-performance machines. They're set up specifically for moving data. They have the proper tools running on them for moving that data and nothing else. And then on the right, another critical component is the ability to test and measure and ensure that things are performing correctly or perform fault isolation if there's a problem. And the standard for doing that in the science community is called PerfSonar. So this is something that is widely deployed in ESNet and other networks across the world. So we can look, let's go straight to slide 15 because I'm just going to speak to the image. So this picture here is an abstract cartoon, right? Nobody's network looks exactly like this, but this is the minimum science DMZ picture, right? It's got the wide area network and with PerfSonar already deployed in it. There's the site border router there, and directly connected to the site border router is this science DMZ switch router. And that is what the data transfer node connects directly to. It's also the device that implements high-performance specific security policy for that data transfer node, and also, by the way, for the PerfSonar host that's connected to it. So if you go to slide 16, and you look at the latency of the different data flows that traverse this thing, remember back to the TCP loss plot that I showed you a moment ago. The wide area portion of the path, right, the long distance part, the part that's subject to performance loss if there's any packet loss, there are only 3 devices in this local network that are part of that long distance transfer. The border router, the science DMZ router, and the data transfer node. That's it. The rest of the network, say this is a large university, right, all 40,000 switch ports in the rest of the university are in that little cloud there on the right that says site and campus LAN, right? But remember that the latency, right, the round trip time between communicating hosts inside that campus network is so low. Again, remember the TCP loss plot. We're up in the upper left corner of it now. Even if there's packet loss going across that firewall, or even if there's packet loss in a wiring closet switch somewhere, the impact will be much less because the distance is so low. So now if we take this model and we were to apply it to a supercomputer center deployment, let's go fast forward to slide 18. There turns out to be a whole bunch of stuff in what we would nominally call the science DMZ, right? You end up with this entire network front end of the supercomputer center in that science DMZ. But if you go to slide 19, you'll see that this is very similar conceptually to the simple version that I just described, right? The wide area data flows just traverse a couple 3 devices, right? The border router, a core, and a front-end switch for the data transfer nodes. Those data transfer nodes immediately write the data to the parallel file system where it's available for analysis on the supercomputer directly. So there's no need to copy the data twice. This is a hugely powerful example of the model. This is what we did in the petascale DTN project. This is what large-scale data portals do. Right? This gets deployed a lot throughout the world. So looking at slide 20, there's a bunch of other designs for this. There's slides at the end of this deck that show some of them. You can look at the documentation on faster data, but there are a couple of common threads that exist in all the examples. One is we build to accommodate TCP and provide it with a loss-free IP layer. And the other is we have the ability to test and verify with PerfSonar to make sure things are working correctly. So now let's talk about security on slide 21. So the idea here is to disentangle the security policy and security policy enforcement for science flows from the security policy and security policy enforcement used to defend business systems. And the rationale for that is that science traffic is actually different than business traffic from a security perspective. It's much simpler and only requires this very narrow application set in order to do it effectively. So a data transfer node might have a data transfer or a data streaming service on it, but it's not connected to printers or no document readers, web browsers, financial databases, none of that stuff, right, runs on the data transfer nodes. None of that stuff lives in the Science DMZ. And so what that means is the security controls that we deploy in order to protect business systems don't have to be deployed in front of the Science DMZ because we don't run those things there as a matter of policy, right? If you find those things there, turn them off, right? That's not the place for them. They go on the enterprise network. So that separation between enterprise or business networking and science networking in the Science DMZ, if we separate those, we can optimize them each individually. So looking at slide 22, so the Science DMZ is actually a security architecture, right? It allows for risk segmentation, and the idea here is to remove degrees of freedom so that we can simplify the security controls and ensure that they're high performance. So looking at slide 23, the reason for that is for scientific applications, performance is a core requirement. Everybody's familiar with confidentiality, integrity, and availability as information security principles, right? We've added performance. We've added a fourth, primary directive here, which is performance. So instead of CIA, we have CIAP. And the reason for this is simple. If we can't get the data that we need, if the performance isn't there, then we can't do the work. And so the science mission fails. This isn't about how much security we have deployed. It's just about how we've implemented the security controls that we'd have to deploy to defend our systems, right? So it's working smarter, not harder. Slide 24, there's a myth about Science DMZ security, right, which is that the goal of the Science DMZ is to avoid firewalls. And that's actually not true at all. Right, the Science DMZ is a security architecture, and it reduces risk, right, by reducing the number of degrees of freedom, reducing the number of devices in the path, and it eliminates performance risk by removing devices that can't perform and ensuring that it's built from high-performance components. So looking at slide 25, right, and this is essentially what I just said, right, the Science DMZ is itself a security architecture. And it's a form of security control, not something that actually needs to be controlled. And the way we do this is through the principle of network segmentation. So looking at slide 26, right, if you think about the rest of your existing network, you're doing network segmentation already. Right, you've separated out your business application networks, you've separated them out from the residence halls, right? If you've got healthcare data, that's on a separate network with separate policy. If you're processing credit card payments, that's on a separate network for separate policy. And why is that? Because each of those classes of traffic all has specific controls that are appropriate for it. And so that's the way we implement it. And so the Science DMZ model is the same, right? We just have a set of things that we do that are also high performance as well as being secure. So slide 27, if we just to wrap this up, the Science DMZ design pattern allows for flexibly supporting high performance data transfers and their associated workflows. And to do that, we accommodate TCP. We put it near the site perimeter if we possibly can so that there are fewer devices in the path. We make sure that we can do test and measurement effectively. We use dedicated systems with a limited application set, and that allows us to perform appropriate security in the Science DMZ. But looking at slide 28, the strategic goal for all of this, right, is to be able to build a data platform on top of the network, right, with the Science DMZ model as a foundation component. And we do that by deploying the data platform software on the data transfer nodes that are in the Science DMZ. And all of those different resources, whether they're supercomputer centers or instruments or satellites or genomics or whatever, can all use that same data platform. So looking at slide 29, this is in service of, from ESNet's perspective, right, our vision is for scientific progress to be unconstrained by geography. right? We do not want the physical location of people or computing or data or instruments to get in the way of science discovery. So slide 30 has a set of links to various content. And that's the end of the talk. Thank you very much. I'd be happy to answer any questions.
Questions from the audience. We can take this opportunity to ask anything to Eli, as he really is the one who coined the science DMC concept. Yes, ma'am. Can you state your name and your institution, please?
Good morning. I'm Vena Pearl Bongalan of the Department of Computer Science. I'm old enough to know that DMZ also stands for No Man's Land. I'm just intrigued. Yeah, it's usually a buffer between two warring states, right? What was your inspiration for this?
So the inspiration for it was very much the network security architectural element, not the demilitarized zone, for example, between the two Koreas. Unfortunately, so we had been talking about the Science DMZ for a couple of years, and my director was meeting with some folks from KISTI in South Korea, and they actually walked up to him and said, you know, this sounds like a really great thing. Can we do something about the name? and at that point we were like, sorry, we've been talking about this as this one thing for a long time. And so this is very much not, it's not intended to be a no man's land at all, and it's not intended to be a buffer between warring factions. It's a specialized enclave that has specific security requirements, and those security requirements are driven by performance. And only by meeting the performance needs can we realize the benefits that we're going to get from deploying the data-intensive science infrastructure that I think everyone here today is interested in seeing prosper, and in effectively utilizing it in order to answer all the questions that we need our scientists to answer in order to solve the problems facing humanity. Right? This is how we're going to cure cancer. This is how we're going to fix climate change. Right? This is how we're going to fix the fresh water problems in so many parts of the world. Right? Is if we're going to effectively get scientists and computing and data together with each other. And there's some specific engineering that we have to do in order to do that.
Okay, thank you, Eli. Any other question? Yes, ma'am. Please state your name and your institution.
Yeah. Good morning. I'm Amor from CLSU. It's quite interesting, Science DMZ. My question is, what are the challenges that I can face in installing that in the HPC that we are trying to build?
So there are a couple of challenges that come with it, I think. One is to make sure that all parts of the organization understand it, and so that it doesn't become something where the security group is on one side and everyone else is on the other side yelling at the security group. Right, because then you have two parts of the organization in conflict, and that makes everything harder. If instead we come at it in a way where we give everyone their role to play, right? So the security group has to defend the systems, yes, but those systems also have to be usable at high performance in order to meet the science mission for which they're being deployed. And so if the computing group and the networking group and the security group can all collaborate on how to do those things well, sites tend to be a lot more successful. The other thing is you don't need to put everything in the Science DMZ. In fact, for a supercomputer center, sometimes the only thing you need to put there is the DTN cluster. And it may not even be all the DTNs, right? It may be that you only put a cluster of 4 machines there. And those 4 machines are the wide area facing interface to the file system. right, and allow for data to come in from the outside and allow users to publish results from there or to share results with their colleagues. Nothing else necessarily needs to be there unless there's a specific operational reason to put it there, in which case you put it there with full knowledge and full support of the security group. So it's not like we have to put absolutely everything there. We only put stuff in the Science DMZ that needs to be there, and we only deploy the applications on those machines that need to be deployed, that need high performance in order to work, right? And that's the stuff we put in the Science DMZ. Everything else, it gets treated in whatever way is appropriate for its deployment and for its mission.
Thank you.
Okay, thank you. Just a last quick question from Bani, Eli.
Hey, Bani.
Hi, Eli. I wanted to ask, when you advocate Science DMZ in the US or in your collaborators, did you encounter any pushback, or was there some kind of inertia that needed to be overcome?
Yes, and a lot of it surrounds security, actually. In a lot of cases, security groups are very used to having everything behind a single point of control that they operate, right? And that's the border firewall. And what the Science DMZ model does is it makes there be more than one of those, right? You've got the border firewall that's for the enterprise network, and then you've got the Science DMZ switch router that controls the packet filtering policy for the data transfer nodes, for example. And so that's something that they're not used to. But the flip side is, if their border firewall can't perform, then in order to meet the science mission, we have to split things in that way. Right, and this goes back to network segmentation like I was talking about before. Right, network segmentation is a security idea. Right, it's just that we have to do it in a way that is accessible to the security group and still allows them the control that they need in order to meet their mission objectives. Right, because if something gets hacked, it's their fault organizationally. Right, and so they have to be able to be successful as a security group. And so this gets back to, everybody needs to be on the same page about it. And everybody needs to sort of grow a little bit to figure out how to operate this thing. But if you want to run at 50 gigabits a second for data transfers into file systems, right, we have to do something other than putting everything, behind a single firewall or behind a single network segment. But that's where a lot of the effort is. The other challenges are sometimes from systems groups who don't want to manage a separate set of machines, right? And it's really useful if you can get them to deploy a separate DTN cluster. And if there's a group, I've run into some systems groups that want to do everything on VMs, for example, right? And so everything has to be carved out of the same VM farm. And that can get architecturally challenging, right? Where it's easier to have just a set of 4 DTNs that are really simple machines, right? 40 gig out the front, InfiniBand out the back, you're done, right? I mean, I've seen lots of people be very successful in deploying that model of DTN, but that requires deploying separate machines, and sometimes that's outside of what people like to do. So there are a couple of challenges, but in general, when people overcome those challenges, they can perform really well, both for themselves and for their collaborators.
Okay, thank you, Eli. I think we have to move on to our next presentation. Eli, we'd like to thank you again for accommodating our request to present. We know it's late evening there in the US. Thank you, and we hope to be able to see more of you, possibly collaborate with the Science DMC. I know locally, Bani and his team are really advocating or plans to advocate Science DMC with universities and research institutions that are our partners in the network. So thank you again, and okay, I'd like to call on my
Thank you very much.
Thank you, Eli.
Our next presenter is a Customer and Technical Outreach Manager for the European Grid Infrastructure Foundation. He coordinates EGI's engagement program and supports researcher communities and educators from academia and industry in tackling big data and big compute challenges using state-of-the-art services from the EGI community. He became involved in grid computing in 2002 and researched high-level user environments and collaborative design tools. Prior to EGI, he worked in training, consultancy, and user support for the Enabling Grids for eScience project from his base in Budapest, where he promoted grid technology and distributed computing practices to scientific communities. To present on EGI's HTC and Cloud Federation, please welcome Mr. Gertschli Sipos. Hi, sir.
Thank you very much for the kind introduction. Can you hear my voice?
Hello, Gertschli.
Hi.
Yes,
Good morning.
yes,
Can you hear me?
Yes, yes, we can hear you.
Okay. I can see the slides. Thank you very much. And thank you for the opportunity to introduce the EGI Federation, which is one of the compute federations and storage federations in Europe. I'm speaking now from Budapest, so it's quite an early hour. I had to find a place in the house which is strong enough with the Wi-Fi and far enough from the fab to take them up. So let me move to the next slide, please, which show the outline of this roughly 20 minutes talk that I have for you. I would like to start with a brief introduction of what EGI is, because it is one of the federations in Europe, but not the only one. Then I will talk about the services that we offer for computing towards scientists, scientific communities, and industry. And then I will focus on how we do this. What are the operational models and the elements of the operation that we do? I will focus on the technical tools. I will talk about the people or the distributed teams that do the operations, and I will talk about the processes by which they deliver the operational activities. I will close the talk with the impact, showing the impact of these operational activities on the users, and I will mention the PRAISE, which is another compute federation in Europe, which, based on the introduction I heard earlier today, may be more relevant for you in terms of high-performance computing. So next slide, please. So EGI, which used to stand for European Grid Infrastructure, it doesn't stand for that anymore. It's just a brand like IBM. Now it's just an acronym, EGI. It was established in 2010 after several years of distributed computing research in Europe. And in 2010, a coordination center called the EGI Foundation was established in Amsterdam Science Park, which is owned by National Grid Infrastructures, NGIs. Currently, there are 22 NGIs plus CERN as an intergovernmental research organization owning EGI and sharing the mission of advancing computing for research. By doing so, they come together, they pay annual membership fee to sustain this federation, both the activities carried out by the EGI Foundation, as well as some of the centrally coordinated activities inside each country, and to deliver services together for the researchers and educators. Here on this slide, you can show the coverage, the geographical coverage of this federation. Together, we run different types of projects to focus activities on special disciplines, on special regions, or special type of communities. Next slide, please. So the most important activity we do is operate a distributed compute infrastructure. And there are actually two types of infrastructures here. One, the bigger one in the top left corner, shows the distribution of cluster resources across the globe. These cluster computers are operated typically by research universities, by research labs. Each node in that network corresponds to a cluster or multiple clusters operated by a single organization. Each of those organizations operates roughly in the range of thousands or tens of thousands CPU cores inside such a cluster. Altogether, that network equals to nearly 1 million CPU cores. The other map shows an emerging federation, which currently has 25 cloud providers, mostly OpenStack-based technology providers, and that is the provider network that is growing, both in terms of number, both in terms of the number of cores of CPUs and recently GPUs that are connected, and that's the network which eventually and recently attracts much more user demand than the traditional high throughput or grid computing network, which is showed on the first slide. Next slide, please. You notice that on this distribution of providers, we have providers outside of Europe, and that's enabled by a memorandum of understandings that we signed with e-infrastructure providers globally. On this slide, you can see the list of providers with whom we have such MOUs. In those regions, those e-infrastructures federate local resources together, and then based on these agreements with EGI, we align protocols, we align behavior, and we align security activities internationally. Next slide, please. How the EGI services are exposed towards users is shown on this slide, which is a screenshot of our website, the services section. And here you can see that the EGI services are grouped into categories. Most important are compute and storage and data categories. Under the compute category, we offer the high throughput computing, which is the grid or batch job execution facilities offered by the more than 200 sites. We have cloud computing facilities offered by the 25 cloud compute providers. We have container computing, and we have workload manager, which helps distribute both high throughput computing and cloud container and cloud compute workloads across multiple providers. Under the storage and data category, we have the online storage, which is typically serving files for the jobs and the virtual machines running in the high throughput clusters or in the cloud. We have archive storage for long-term storage space, and we have data transfer service to move big data sets among providers and from user or research site to the compute facilities. We have security service called check-in, which enables single sign-on federated access to the technical services in the EGI Federation or beyond that. We have application services that provide high-level virtual research environments, pre-configured scientific applications on top of the compute and storage infrastructure. And we have training services, FITSM, about which I will talk about, ISO 27000, which is a security standard, and we offer a training infrastructure, which is a cloud-based facility for trainers, educators who want to deliver software courses. So many of these technical services have ready-to-use instances, which are easy to use with minimal time to request and to gain access, while communities, scientific experiments, scientific projects typically require dedicated allocation of these capacities. The next slide, please. Can you please proceed? Yeah, okay, it's coming. For these scientific communities experiments, EGI acts as a negotiator or broker that brings together the demand, the requirements of the community or project with the facilities and the capacities that are offered by the EGI members and the providers in the EGI network and partnership program. These demands and provisioning conditions are brought together and are secured through service level agreements that EGI signs with the project or scientific community. Based on those service level agreements, the providers deliver the capacities, whether it's a cloud compute, storage, or training and support. The SLA defines the availability times, the time to respond, for example, to have this request, protocols, how to make changes, how to inform the customer about changes in the infrastructure and in the configuration. And based on these SLAs, we generate performance reports for the customer on a regular basis that informs the customer about the behavior of the infrastructure about the recent period of time. Next slide, please. And this activity that's facing towards the user communities lays on 3 pillars of operations. These 3 pillars represent all the technical infrastructure that the operation teams in EGI use to make sure that services are accessible and properly working. They include the teams themselves that are distributed in the whole federation and look after the sites. And we have processes which define and guide these distributed teams the way how in which they should deliver the service themselves. So let me now show one slide about each of these 3 pillars. The next slide, please. And let me start with this technical tool, which is basically a portfolio of services that are operated on behalf of the EGI Federation by designated and agreed members of the Federation who are responsible for the high availability delivery of these central tools, which is used by everyone in the Federation. Let me just briefly go through these one by one. And there is, I think, some animation on this slide. If you just click one, then it will add some more information about the first element, which is the website and marketplace, which is basically the entry point for the users and user communities to discover the services we offer, to find pre-configured instances of the services, or to request community-specific instances. The next one is the check-in, the access management system. All the compute and storage facilities are hooked into the check-in service, which enables federated single sign-on with academic EduGain-based accounts, or depending on the strength of the identity vetting, even with social accounts to the services. The third is a configuration database, which is an information system where the endpoints, the service endpoints are registered, and this is crucial in order to do, for example, the monitoring, which is the next element. The monitoring infrastructure in EGI performs regular checks of all these configured endpoints. The checks are specific to the type of points. Different tests are run for the batch computing queues than for a cloud computing environment or for a storage system. These probes or tests are configured by the central operation team when a new endpoint is enabled. The accounting system also relies on the configuration database and basically pulls together usage information about all of these endpoints, aggregates this information, and presents them in different views to show trends, to show usage by community, to indicate usage in a given region or at a given site. And the last tool that I would like to mention is the distributed help desk, which is used, for example, by the monitoring system to open event tickets when a service is recognized to be unavailable. It's also used by, of course, users and user communities to raise questions to replicate, which is then routed to the providers or routed to the expert teams who are answering to those requests. The next slide, please. The second pillar of the operation is the distributed team who makes sure the services are available and accessible. And this distributed operations team is, on one hand, organized into a hierarchical structure, starting from the site level, At every participating site, there is one or more service operator who is responsible for the site-specific services, to responding to incident tickets relating to those services, making sure the services are up to date in terms of software and in terms of configuration. At the national level or country level, the NGI operations manager oversights the national landscape, validates new services as they come on board by the providers or by new providers of that country, and brings that knowledge back to the country through the operations management board, which is organizing regular teleconferences for these national representatives. The third level in this hierarchical structure is the foundation level. There is a central operation team in Amsterdam who oversees the whole federation, who organizes regular teleconference meetings or face-to-face meetings for the members, and who define the IT service management processes relating to the operations. I will talk about these processes next. And then there are special teams focusing on special topics. Out of these, the most important ones are listed here. On one hand, there is a computer security incident response team, which is monitors security incidents and alerts, opens alarms to sites or to software teams, depending on the nature of the incidents. There is a security monitoring team, which checks for vulnerabilities and points out weaknesses in certain sites or certain configuration options. And there are training teams specialized on operational aspects. Next slide, please. The third topic in operations is the processes, or in other words, the guides that the operation team follows in order to ensure the high quality of the IT services. These guides are organized in EGI based on the FITSM IT service management practice, which is a lightweight and open standard, which is freely available to anyone to organize the way how IT services are delivered by an organization or by a federation of organizations. FITSM helps this organization through 14 processes and requirements linked to those processes. And if you go on with the animation, then you will see some examples that out of these 14 processes, there are things like service portfolio management, which defines requirements on how organization or federation service portfolio should be managed. Service level management, incident management, defining how incidents should be dealt with. And if you go on with the animation, you will see some very specific examples that for the capacity management process, FITSM says or states 4 requirements, things like capacity for the service instances, performance requirements shall be identified, taking into consideration the service level agreements that are in place with the customers. Capacity plans shall be created and maintained by the providers, and so on and so forth. So these requirements and meeting these requirements helps EGI to professionally operate the services, and between EGI that we designed the service guides and the management guides based on these FITSM requirements. We provide regularly FITSM trainings for both the EGI members and also for certain external parties. And we organize different types of workshops to help the different compute centers implement FITSM at their site in the context of their own service portfolios. Go on, please. And the impact of all these operational aspects are summarized on this slide. So I mentioned in the beginning that there are more than 200 high-throughput compute sites in the EGI Federation. There are 25 cloud sites. All these together expose more than 1,000 service endpoints, compute, storage, container storage, and so on, types of endpoints. There's a continuous increase in the use of these endpoints. 12 research infrastructure communities are relying on this infrastructure and using this for their domain-specific activities. I see Suhami's slides. Can you switch back to my slides? Yes, thank you. The security incident response team recognized nearly 50 vulnerabilities in the past year, and 41 new community allocations have been set up in the year. And another aspect of this work is that it was recognized as a best practice or good practice in Europe for federating distributed operational activities. And in the recent huge European initiative called European Open Science Cloud, the EGI operational pillars were chosen as the baseline for organizing the operations. So now, since 2018, there is a 33 million euro project called EOSC Hub, which defines and delivers the service integration and management system of the European Open Science Cloud. This project is coordinated by EGI, and through this project, we bring the EGI operational tools, practices, and policies and processes into this bigger European Open Science Cloud context, widening or broadening the scope of operations from the computer data area to other areas that are relevant for EOS. And let me go to the next slide to close the talk with one slide showing PRACE, which is another compute network in Europe. That's a partnership of the largest supercomputing centers of Europe. I'm sure that many of you are familiar with this. PRACE is organized into so-called tiers. The biggest computers of Europe are in the tier 0. You can see France, Germany, Italy, Spain have computers in tier 0 allocation. The smaller ones are in the so-called tier 1 center, and these together are agreed on the scheme for allocation of resources to scientists and scientific communities. This is done through a peer review process in which researchers have to apply for CPU time on the machines. It is brokered to the best matching architecture and site, and then the respective PRACE partner who delivers that computing time for the researcher is responsible for the support of the researcher or for the industry user, depending on the nature of the use. So let me go to the last slide, which is just the thank you slide, and also mentioning a few upcoming events that are in the EGI context. The EOSC Symposium, which is the European Open Science Cloud big annual event, will be later this month in Budapest, the city where I'm speaking to you now from. The EOSC Hub Week, which is the annual event of the EOSC Hub project, will be next May in Germany, in Karlsruhe, and the EGI community will have its annual conference in the early summer next year in Lyon, in France. So if any of you are interested in following up discussion, then these are excellent opportunities for you. Thank you very much.
Any questions from our audience for Gurjali? Yes, I have a question. Gurjali, if outside of Europe, for example, here in the Philippines, if we are interested to access any of the tools that you're offering on the EGI site, can we do that, or is it just for European partners?
No, you can do that. To use the operational tools, we need to discuss the membership options, because these operational tools are available for countries which join EGI as member of the federation. The membership fee depends on the country GDP. I need to check what it would be for the Philippines.
Okay. Okay. So thank you for that. And certainly, I think on the last slide, we would be very much interested in that because we know that Europe has been leading in terms of federating networks, federating HPC and clouds since the early 2000s. So ASEAN, the Philippines and the ASEAN has a lot to learn from the Europe experience. So before I say goodbye to Gertrude, because I think it's around 3 a.m. in Budapest. Is that
and at 4 a.m.
So, is there a 4 a.m.? So is there any last question? Okay. So with that, Gertrude, thank you again, and I hope to see you again in a future meeting.
Thank you.
Okay, thank you. Bye-bye.
Bye.
Okay. Okay, so I'd like to call on Charmaine for our next and last speaker for the remote presentations.
Our next presenter is an associate professor and deputy director at University Putra, Malaysia. He succeeded to bring the first ever bioinformatics computing facility of Australian National Genomic Information Services to Malaysia and was instrumental in the initiation of the Malaysian Bioinformatics Network and Asia Pacific Bioinformatics Network, or the AP BioNet. He was involved in the various phases of testbed environment for multimedia applications and networking, and the Malaysian Research and Education Network projects, with the ultimate aim of forming the future core infrastructure of Malaysia's education and research. Dr. Suhaimi co-founded the Secure Identity Federation on Unified Lightweight Access Management, Malaysia's Authentication and Authorization Infrastructure Trust Framework in 2014. He has been involved with APAN since its formation in 1997, and he has also been a key player and member of the Trans-Eurasian Information Network, or TAIN. Through his personal effort, Malaysian Identity Federation and Access Management has been approved as a member of International Grid Trust Federation and is able to issue grid user certificates for the Malaysian research community. Everyone, please welcome Dr. Suhaimi Nafis. Hello, sir. We cannot hear you, sir. We still can't hear you, sir.
Yes, can you hear me now?
Yes.
Hi, sir.
Okay. Hi. Okay. Thank you very much for the kind invitation to actually to me. And I'm so sorry that I'm supposed to be there in person, but unfortunately due to some personal tasks that I have to endure, I won't be able to be there. I know Dennis was there just now, and I'd like to actually say thank you, the Undersecretary of ICT. I've known Dennis since the very beginning of APAN. Also, the Director of ICT, I forgot the name, never mind, let me check. Dr. Joel Marciano, and of course, my good friend, Peter Banzan. Hello. Okay, my talk today is on the development of ASEAN Federated Identity and Login Management, or ASEAN FILM, and collaboration with Galaxy ASEAN Community as a use case. Next slide, please. Right, as has been mentioned, I was the one who actually founded and developed from the ground up the Malaysian Access Federation in 2014, and it has been accepted officially as the 57th member of the EduGain, which is a major milestone for us in Malaysia. So we are now being able, or at least our Identity Federation members would be able to collaborate seamlessly with Europe and the rest of the world. Next slide, please. Right, moving back towards the ASEAN HPC Facility Task Force, whereby this ASEAN Film is actually the project that is accepted as been under the ASEAN HPC Facility. So we do have, as has been mentioned, also with Peter Benzen, the ASEAN HPC Task Force for the sharing of HPC among ASEAN members. The objective, of course, to develop the access for HPC and to be able to share and create opportunity and talent for all ASEAN member states. Next, please. Right. While we were doing that, and I'm being tasked together with my colleague, Mr. Farhan, we have some implementation concern when dealing with the ASEAN member state researchers. We just want to, to consider which implementation model we shall adopt for the shared infrastructure, and how users from among ASEAN member states can access the shared infrastructure, which trust framework shall work, and how does the application domain communities can make use of this soon to be, hopefully, the shared infrastructure. So these are the questions that is our concern, and this is what we hope to address, because we always believe that when it comes to having a shared infrastructure, the ability for us to attract users to use will be the key. So that is why we were thinking about killer apps. And of course, next slide, please. Of course, maybe we will talk about the Galaxy community later. But for the ASEAN film, just to briefly mention, it's a project under that task force, and it was approved in Singapore, our second ASEAN HPC task force meeting last March. So it's still not yet 1 year. We aspire to have a single sign-on to facilitate login and access to ASEAN e-research shared computing resources. But we do not want to actually reinvent the wheel. We want to leverage on the existing inter-federation infrastructure, namely, I think, the EduGain, as well as whatever that we have gathered together with the Philippines under the Asia Pacific Advanced Network Identity and Access Management Working Group. And I think several people from the Philippines, they keep changing, that attended the APAN IAM Working Group. So I think it's been going on for the last 2 or 3 years, and it's finishing, but hopefully the next stage whereby they can apply for the Asia Connect, we would be able to bring in more people, but let's be hopeful on that. So Sifulan is taking the lead on the project with the support from other identity federation, and I have to mention Singapore Access Federation as being our key partner. Next, please. So when we talk a little bit about IAM working group of APAN, we have generated great awareness and understanding among identity and access management. 9 out of 10 ASEAN member states are members of the APAN IAM working group, and I'm quite sure Philippines is one of those that are in the group, which has been attending the session for several of the previous APAN meetings, including APAN Malaysia, if I'm not mistaken. Next, please. So this is the Korea, APAN 47. I'm not sure whether you can see anyone from the Philippines. You can see from anyone from the Philippines that you can identify? No? Yes? Maybe no. Okay. These are the people. And next. All right. So what would be the ASEAN film design? This is actually roughly, I don't want to dwell into too much detail, but it is based on JON AARC, Authentication and Authorization for Research Collaboration. The technology used will be built upon SAML protocol, but we are not going to limit only to SAML protocol. We are looking at also supporting other protocols such as OpenID Connect. And of course, this is something my plea to all of you in the Philippines. I am unsure whether the Philippines has actually started, initiated, or have actually formed the National Identity Federation of the Philippines. So with this case, in this case, we will be more than happy to provide assistance to the Philippines. So I put a question mark in red there because I am unsure of the status of the National Identity Federation development in the Philippines. Next slide, please. So this is just the Galaxy RSCN community. As I mentioned earlier, me being a molecular biologist and bioinformatician, we being also together molecular biologist and bioinformatician, and the developer, the lead technical developer, Farhad, is also in bioinformatics. It's only obvious that we consider Galaxy Bioinformatics community as the one that we would like to target. So this is the Galaxy ASEAN community. Next slide, please. They had a meeting in, where is that? In Kuala Lumpur in 2014, and actually they had another meeting just recently during e-research Australia. So next. So the initiative was kicked off in, where is this? Okay, in COP 2019 is in Indonesia. During the 18th International Conference on Bioinformatics in COP, and the aim generally is to foster interaction between Galaxy user in ASEAN region, and of course to enable the scientists to set up or to have access to common analysis workflow and standard, and most importantly to provide training in this aspect. Galaxy ASEAN model has a predecessor, namely Galaxy Australian community that has been well established, and of course Pradana University will be the School of Data Science that is taking the lead in this initiative. Next, please. So the ASEAN or Galaxy ASEAN infrastructure, just to dwell a little bit deeper, will be implemented as a federation of Galaxy computing resources, whereby each ASEAN member state may contribute their computing resources or run on top of the proposed ASEAN shared HPC facility in which the task force is pursuing. And of course, I have already mentioned it will be modeled after the Galaxy Australia infrastructure, which has successfully aggregated several computational resources from several research centers in Australia to form a federation of Galaxy resource. Next slide, please. So putting them together is putting together something that has already been existing. ASEAN HPC facility, we have the task force. Galaxy ASEAN is actually, they already have a model after Australian Galaxy. And of course, the ASEAN Film, all three of them will be a perfect use case for ASEAN research solidarity. And this is what Malaysia, Philippines, and the rest of the ASEAN member states would like to see in the future, the capability of the ASEAN research to be solidified and to work together towards the advancement of each and every science and technology development. Next slide, please. I don't want to dwell into that, but this is the pilot test architecture, whereby if you notice down there at the bottom, left side is Malaysia Grid, the Galaxy Computing Node, and then followed by Singapore Galaxy Computing Node. And then we hope that the other ASEAN on the right-hand side there will also chip in to make it as the ASEAN Federated or ASEAN Galaxy Portal to be able for each member state researchers to have access. And of course, on top of that would be the ASEAN Film Proxy Server, and also the Discovery Service, as has been mentioned by, elaborated by Gerge Shipos just now. They also have the login or the common place where they aggregate and where each and every services can be discovered through Discovery Facility and Metadata Service. And of course, we also have some other like the AMS member federation that is going to chip in, as well as some proxy for those who have not been able to immediately do the ASEAN, national federated identity. So that's basically what it is in a nutshell. Next, please. This is the timeline. It's very tight. We just have October and December 2019, as we are now doing some implementation and testing, and hopefully we will be able to have a field test in early January next year. And we are targeting the second quarter, which is actually end of March or early April, to go into production to facilitate the collaboration among the ASEAN member states. Next, please. So this is actually something in which will be beneficial for us in the ASEAN member state, whereby there is an initiative to bridge ASEAN with the Australian e-research community, and this is also again in a sing-song together with the ASEAN, together with the Australasian, sorry, not Australian, but it's Australasian e-research community to bring on a larger scale beyond ASEAN. There will be an increase in exchanges between ASEAN and Australasian research community, participating in many of the forum, conferences, and so on. And we would like to have the training and education and promotion to be increased, especially on the postgraduate program. And we hope, okay, that we have access as the ASEAN member state to the Australasian e-research infrastructure. And as been mentioned by Eli just now, research data exchange and management will be the key towards the collaboration. So Malaysia certainly do not have a science DMZ yet, and I'm so happy to see and hear Bani is embarking on the Philippine Philippine demilitarized zone. So this is something in which we Malaysian would like to learn from Philippines. Next, actually, is the last one. Okay, these are the project member and partners: Indonesia Access Federation, Singaren, Sifulan, Perdana UPM, Galaxy Australia. There you go, National Supercomputing Center, Tinwi initiated, Tinwi, what they call that? First presentation just now talk about the possibility of making it bigger. Some 200 million Singapore dollar is going to be poured in, and hopefully the other ASEAN member states will be able to utilize and use some of that facility. And of course, AP Bionet and APAN. Next. These are the people I'm leading together with Tinwi and the technical coordinator Muhammad Farhan, Asif, Rafsif, Kenneth, and all the rest. And I hope to see the Philippines to be, the Philippine researcher or from anyone from ASTI to actually be joining together in the very near future. With that note, next. Thank you very much.
Want to see participation for the Philippines, particularly in the ASEAN Film initiative, since we are also part of the ASEAN HPC Task Force. Any question for Suhaimi? Actually, in answer to your question earlier, if we have a federated identity, right now we don't have that, and that's what we want to adopt. Whatever initiative will be put in place in the ASEAN HPC Task Force, especially in this one, the ASEAN Film, is what we plan to implement locally. So, like you said, we're not starting from scratch. We're not reinventing the wheel, but what we have currently in the international scene, and international initiatives that we are participating in, this is something that we want to cascade locally to our scientific community. So yes, I guess it's safe to say that please expect more Philippine participation in terms of the Essay and Film initiative. Okay, and we'll give you a name. I guess aside from Sir
Okay.
Peter and Bani, so that every APAN there will be one one participant from the Philippines that you will encounter in the, especially in the Identity Access Management Working Group. Okay, so
Yeah.
any other questions for Suhaimi? Okay, so Suhaimi, thank you so much.
Can I say my last word? Can I say
Yes,
my last
sure,
word?
sure.
Okay. Peter and Bunny and everybody, we are very close to the Philippines, and we will be very happy to render our assistance in terms of the development of the Philippine National Access Federation. Because the key to the ASEAN film would be to develop each and every ASEAN member state its own national identity federation, and then the collaboration will be the ASEAN-wide, and then we will be able to render the assistance right up from the very beginning in the initiation up to the becoming the membership of the EduGain. So if I may say, Indonesian Access Federation is the upcoming, and I think in the Philippines, in Thailand also they are embarking on this. So I hope that the Philippines would be the next one. And like I said, Air Asia is so cheap to go to the Philippines, and then we could just easily, with a short notice, to come and give you some sort of assistance. Thank you.
Okay, thank you, Suhaimi. I'm also taking note of the timelines that you have on one of your slides in terms
Okay.
of
Okay.
So thank you.
Thank you.
So Charmaine.
That ends our remote presentations for this event. We will just be having a working break, so if you haven't gotten your snacks yet, you can go to the back of the room and get your snacks. We will move forward to the next part of the program, which will feature updates on DOST ASTI's S&T infrastructures. Our first speaker for this session is a supervising science research specialist at the DOST ASTI, and he currently leads the PREGINET group, where he started in 2003 as a network administrator. He is the currently only remaining guy in PREGINET who saw the network through from the days of 256 kbps connectivity up to the present, where PREGINET is now in the 100 Gbps league. He calls himself the network janitor. Please welcome Mr. Bani Lara.
Okay, so good morning. I hope you're enjoying your snacks. I'm Bani Lara, and I'll be giving you a perspective about the science infrastructure that we are using from the lens of a network operator. So not really a hardcore science guy. Okay, so this is the network of PREGINET as of now. I just emphasize the uplinks going to the research consortiums that we are partnered with abroad. We have a 10 gig link going to Hong Kong, connected to several institutes there. Then we have another 10 gig link and a historical 1 gig link going to Japan. So we have technically a 11 gig link going to Japan. Connecting to the APAN consortium, the one that Suhaimi mentioned. Then we were able to have a Singapore link, a 10 gig link up and running, connecting to the PREGINET there called Singaren and to Singapore Internet Exchange. And this is more or less what the network looks like in terms of summarizing all of the major backbone links connecting the global research and education networking community. Here's another map showing the United States backbone, Internet 2 specifically. We have Red Clara in the South American region. We have Giant in the European region. And we have a middle project called Asia Connect, connecting the European region to the Asia Pacific Research and Education Networks. So I'm not sure if you can see the Philippines has 4 links, 2 links going to Japan, 1 link going to the Hong Kong aggregator, and another link going to the Singapore aggregator. Okay, so to summarize it all, this is what actually a research network or PREGINET looks like. It's a middleman between the users and the high-speed research backbone that we connect to abroad. Then we added a third component. It's also a middleman going to the commercial network or the commodity internet that we term. Okay, this is more or less the network that we are used to. This is what the orange box. This is the network that we have at home that we get from PLDT, from Globe, from Buy-and-Tel. The green box. This is what more or less DOST and the other funding institutes pays for us to get high-speed access. Then the blue box is the domestic network to connect schools, research institutes, and other stakeholders of PREGINET. So I have this line here to show that you can actually access, for example, a research network on the green box through your PLDT, Globe, or Converge line from your home or from your office. Okay. But the benefit of passing through the green box through PREGINET is these are more or less high-speed links. So if you're transferring just bursty traffic, for example, email, FTP, video, the smaller traffic, you can use the commercial internet. But in terms of research networking, if you're passing gigabits of data sets over your pipes, then that's the value of a research network. Okay. So what exactly are we doing inside the network? Okay. We're doing videos, okay, lots of videos. Okay. Videos that we try to waste our time with. Okay. We stream videos, so if you can see the 2 televisions here, that's the 2 televisions at the back of that wall. So the UP Computer Center usually streams videos of UAAP games. Okay. We're in UST map UP on the floor. Okay, so UP right now is struggling in terms of UAAP. Sayang wala na si Owe ng Lasal, tinalo ng UP. But we have one more chance to reach the finals tomorrow. So sana manalo, or tomorrow. Okay. So why do I emphasize this content? Okay. Other research networks, usually, it's more of a research network, specifically research network that's traversing over the network. Okay. In terms of PREGINET, more or less, it has evolved into, I'm not sure if the term is right, into a general purpose network, wherein research traffic, government traffic, and other non-science traffic are passing through. For example, UP Computer Center streams basketball games. Is this academic? Is this scientific? That's debatable, right? But it's a UP activity. The fact that it's a UP activity, should it be tagged as academic? Or is it a waste of bandwidth? Okay. So I have no answer with regards to that. The point is, the network has already evolved into having different purposes, okay? Not just transferring satellite images and all of those weather data traffic. It's also being used for other purposes, okay? In my long years with PREGINET, I think the Philippines will find it difficult if we become purists about the network. It's very difficult to sustain a network. The lease lines are very expensive. And if we put up a network just for a single use, then we have to pay for everything. But if we partner with different entities and share resources, and I think that would be a more sustainable model. Okay. So when we started Preginet before, Sir Dennis, we didn't have any commercial internet over Preginet. If you connect to Preginet, you just get a PAN, you just get a group called AI3. Basically, you just get access to science materials. There's no Google, there's no Yahoo pa siguro yung sikat nun. None of those commercial traffic can be done over the network. The problem is it was quite difficult to sustain because the link from Quezon City going to a state university somewhere is quite expensive, and the university pays for that. Okay. So besides those activities that waste our time and bandwidth, what else are we doing inside the network? So hopefully we're doing research, or hopefully you guys that are connected to Preginet are doing research. Data needs to be imported from outside sources. This is an old slide, but I usually emphasize it because the operators of Internet 2 in Indiana University tagged actually the Philippines. Not as an abusive user, but as one of the users of the American network that's pulling a lot of data from a US source. So it was hitting their net flow feeds as one of the big users of their network. So what exactly was Philippines doing? Bert was torrenting. Joke lang. Bert is over there at the back, and he was, ikaw to Bert, diba? You were pulling weather data from NOAA, from NOAA, the Pag-asa equivalent of the United States. Okay, and what was Bert doing with all that data? He was giving it to DA over there. Okay, back then, the NOAA project was very active, and we were getting a lot of data sets from all over, so that DA over there can play with the data and visualize it and give it to decision makers. Okay. So, ayan si BA, the presence of hazards does not always lead to disaster. So, parang prophet ng dating. Okay. Then, dito sa slide na to, usually maririnig mo to sa office. Nag-YouTube lang. Nag-YouTube ka lang. Nagsasayang ka lang ng oras. Pero actually, if you look at this, part of NOAA's initiative of visualizing things over a website is their very active social media people. Trumpeting, you know, the maps, the PDF files, and all of those things that they produce. Right now, it's not enough for us to put our information in a website. That would be the formal way. Pero right now, for us to reach the most people that we can, we need to be active in social media. Okay. So in fact, ASTI right now is a heavy user of Facebook and YouTube marketing. You can see it on our Contact Us website. And as of now, as this meeting is happening, Jeng's colleagues are putting what we're doing here in Facebook. Tama ba? So posting it real time para yung mga taong hindi nakapunta sa kwarto na to, updated din dun sa ginagawa natin. Okay? So, because it's quite difficult to get them all here. As evidence nung speakers natin, puro mga remote. So, sayang umalis na si Sir Joel, pero usually yung isang speech ni Sir Joel nun sa celebration ng Internet 30, I think, 25 years of Internet last year, is for us to make Internet disappear in the background. Parang, ano yung term niya? Parang kuryente, parang tubig. Pag pumunta ka kahit saan, you assume that it's there. Part na dapat siya nung infrastructure. Hindi mo na dapat siya pinaproblema. So, right now, if I go back to this example, ang YouTube hindi na natin pinaproblema. Or at least if you talk to the social media people nila Jeng, problema pa ba mag-upload? Mabagal pa ba? Hindi nag-upload yung file, nag-hang? I would think hindi na siya problema kasi Wi-Fi is all over the place. And our access to these social media platforms is already quite fast. Kung maaalala nyo, 10, 15 years ago, ang YouTube may umiikot pa na, hindi naman siguro 10 years ago, basta dati ang YouTube may umiikot pa na buffering, di ba? Papaload mo muna yung video bago mo panoorin. Okay? So, the point of it all is a lot of work went into PREGINET to make your YouTube load fast in order for your science to reach the non-science people. Diba? The science people, we put it on very high-tech PDFs and upload it sa website. Pag ipupush natin yung science natin sa non-science people, kina Juan de la Cruz, we lamanize it as much as possible, and we put it usually on social media platforms or on television para mas maintindihan, mas maging palatable sa sambayanan. So, those platforms, specifically yung YouTube, yung Facebook, a lot of work went into actually lobbying for funds to get a 10 gig link to Hong Kong, to put an expensive router there, and to actually beg or magchami-chami sa mga Google people para makappear tayo sa kanila. Okay? So, a lot of effort went into inviting caches to locate within the network. When we were asking content providers to locate caches within PREGINET, it's not as if sobrang laki yung network tapos automatic yung decision sa kanila. Hindi. Actually, maliit yung network. And these multinationals actually struggled on deciding if they will locate their caches within the network, simply because traffic was quite low. Okay, so we had to literally beg them to put caches here. Okay. In fact, si Google actually wanted to pull out kasi mababa yung traffic niya dun sa caches. So after begging Google, I had to beg specifically UP Diliman to turn on YouTube para tumaas ang YouTube traffic para hindi mag-pull out. Kasi pag nag-pull out yung Google, hindi lang YouTube yung talo eh. Lahat ng kinakache na content ng Google dun sa servers nila sa ASCII, hindi na local. Balik tayo na kukunin natin abroad yon. So, talo tayo dun sa bandwidth. Okay, so what else do we do within the network besides making your social media fast? We connect the dots. Okay, so within ASTI, there's a group that Sir Dennis actually mentioned kanina, yung weather sensor group that has scattered, I think, 1,500, 2,000 sensors all over the Philippines. And it's visualized through this website. I'm not sure if you can see it, fieldSensors.asti.dosd.gov.ph. Okay, so it's collecting a lot of weather parameters to be able to visualize what the country looks like mula sa terrestrial na perspective. Okay. So they put a lot of these devices in very remote areas, near rivers, and all of the other places that Pag-asa thinks a device like this should be installed. So how is PREGINET linked into that? These devices have an SMS module on it, a SIM card, to send the weather parameters back to the mothership. And within the mothership, within ASTI, is this device, an SMS gateway, that converts the data being received from a lot of these SIM cards into this RJ45 port that turns it into IP data, data through the IP infrastructure. Okay, so it will be put into a server for researchers and the Weather Bureau to use. The network right now also delivers useful and actionable information to decision makers. So banggit din ni Sir Dennis kanina, nag-uumapaw na ng data na sinastore sa science infrastructure. It has to be, we need people to pick up the data and translate it into information that we can actually use. So one such initiative of ASTI is called Datos, and they do a lot of hackathons in order to encourage programmers to convert data to information. This is one output that they have. Hindi ko na-interpret, hindi ko masyadong, hindi ko alam kung tama yung words ko. Bottom line, there's a flood and they gave this to NDRRMC for them to be able to advise people to flee the hazardous zones, okay, using data modeling and satellite images. Okay. So going back to the network discussion, these images that they send to NDRRMC runs over the network. And actually, that is thanks to the government network that the DICT is doing. People from the science side, ASTI, DOST, are able to push large images to a government entity. And if actually compurist yung PREGINET, baka hindi namin na-connect yung NDRRMC. Kasi wala masyadong science or R&D doon. That is government coordinating body. So hindi namin uunahin i-connect, uunahin namin yung state universities. Pero yung output ng ASTI, kailangan ibigay sa kanila. So buti na lang may network para ma-send sa kanila agad yon. Okay. Okay. Lots of images are also being moved within the network as of now from these facilities in Quezon City in ASTI, and in the future from this facility in Davao, going to these laboratories. A laboratory on space training was created at UP EEE, and hopefully they will produce a bachelor's degree on space science, I think, or graduate studies. Then satellite images right now, or actually data sets from ASTI are being pulled by PhilRise. Okay, and we actually went to PhilRise earlier this year and met some of those researchers. And before, they were actually commuting from Muñoz to ASTI to bring their hard disks in order to copy the images that they need. Okay. Fairly recently, we were able to connect the Muñoz area to ASTI, not PhilRise specifically, Central Luzon State U. So Sina Sir over there is connected to ASTI. Then we asked PhilRise, while they're working on the link from PhilRise to CLSU, maybe instead of going all the way to Quezon City, they can just go a few kilometers to CLSU to access PREGINET there. Okay? In order for them to do their rice science, which is to do Duterte images on rice fields and do ALDAB images on the rice fields. Mas seryoso yung science nila. Marami silang ginagawa. Okay. So, one story there is, so may gap from PhilRise to CLSU. That's around, what, 3-4 kilometers, if I'm not mistaken. So, that gap needs to be filled. We approached the Muñoz satellite cable if they can give a quotation to lay fiber or have a fiber pair be laid out for use of PhilRise in order to connect them to the state university. Okay? Then willing naman si Muñoz to do it. And since medyo academic yung engagement with the CLSU and PhilRise, nagtatanong din sila, baka pwedeng makakuha din sila ng training on internet. Kasi gusto rin nilang matutunan yon. So that was actually interesting kasi they have cables all over the place, fiber optic cables and coax cables, and yet kulang pa sila sa know-how on internet. So interested naman kami na tumulong mag-training. Okay? So ang relation nun is Ma'am Neng is here, FICTAP, and I think sina Sir Pinor, members of FICTAP and PCTA. PREGINET should not be a purist in terms of doing everything, laying all of the infrastructure on their own. We need to partner with a lot of entities, and doon sa pinaka rural, na medyo hindi na naaabot usually ng PLDT or Globe, actually very critical yung cable operators in order for us to reach the state universities that we want to reach. There are around, I think, 200 state universities that needs to be connected. Okay, so cable operator, usually hindi science, hindi academic, pero PREGINET needs to work with them because we need the infrastructure to connect our collaborators on the far end. Internet exchanges. So how do we also assist cable operators? We're actually running an internet exchange, and if a cable operator is able to connect to it, the same YouTube, Facebook, Akamai caches that I talked about earlier, we share those things also, hindi lang sa academic community, pati sa internet exchange. As long as you can connect to it, you can access it. Okay. Within the internet exchange, we run the yellow pages of the internet called a domain name system. And right now, ASTI is hosting 5 Anycast instances, basically mirrors of the DNS. And what's good is nag-attend kami recently sa AI3 Soy, and they're also gonna deploy an mRoot. So magiging 6 na yung root servers na naglaran dun sa network. That's basically good for us kasi Yellow Pages nga, in order for us to access a website, we need to know yung number, yung IP address to access that website. We don't memorize the numbers. We just know the name. So, trabaho ng DNS to record all of those numbers and search the internet. Another development in terms of the internet exchange that we are running is, I guess for the routing guys, usually useful sa inyo yung route views if you're troubleshooting routing problems. Before we access this abroad, right now, naka-peer na sila directly dun sa internet exchange, so there's a local instance of the route views project. Okay, so right now medyo mainit yung discussion about setting up internet exchanges specifically for R&D, for research and development. Okay. The Americans, a big group, Pacific Wave, and another big group in the US Internet to have actually partnered to set up APREX Exchange Point, Atlantic Pacific Research and Education Exchange. So sumasali na rin sila dun sa Internet Exchange bandwagon. The Chinese University of Hong Kong, they actually set up a router in a building in Hong Kong specifically for research networks to connect to. Singaporeans, sina Tan Tin Wee, or specifically sina Francis ng NUS, have set up a Singapore Open Exchange, and NUS is the one hosting it. Okay, so what else are the things that we do over the network? Term ni Sir Roel, collaboratory. We do collaborative activities over the network. And I highlight one specific project called Prime, wherein they set up collaboratories, both local and remote, to be able to bring up the infrastructure there, upgrade the network in order to mentor students and do distance learning activities. So I think the aim is you can get UP units or UP degree, even if you don't have to go to the UP campuses that often, I think. So right now, these are the universities that are connected, both public and private sector, and pinapadami pa ng pinapadami yung mag-connect. Future upgrades. We're setting up, or Bert, tapos na ba? Na-set up na. 100 gig link between EEE to ASTI. So Bert will now be called the father of 100 gig in CP Garcia. And we're trying to finish procurement to finally set up a link to the United States. Although aabutan na ata siya ng Facebook cable nila Sir Dennis. So if timing is correct, sir, on time next year po ito na 2020. Around March, the Facebook, the collaboration between the Philippine government and Facebook, PLCN, hopefully will be, hopefully the circuit will be established na. Po. So bibilis dapat yung Facebook, makakapag-upload pa sila ng more videos in real time. Okay. Pa. Tuloy daw po. So 2 terabits going to Hong Kong and to US. Okay, so that's it for my presentation. You can download the slides here. I guess my final point would be yung research network, may hirapan siya kung pure lang siya na dun lang siya sa science community iikot. Ang hirap ng pera, ang hirap mag-propose. He has to think out of the box and find allies and partners to expand the network. Otherwise, popondohan niya lahat and ang hirap i-sustain. Okay. So, thank you.
Okay. Thanks, Bani. I guess yung presentation din ni Bani shows how, I guess, ready yung Preginet is for any, like for example, right now we're coordinating with UPNIP. Kasi they're going to participate in a CERN experiment. So we're trying to get ready in terms of yung network, in terms of yung HPC resources for that collaboration. So yun. So yes, Bani.
Actually, to add dun sa example ni Jeng about the physics people in UP collaborating, yung isa sa mga main collaborator nila all the way dun sa Iligan. So yun, nahirapan kaming i-connect, pero na-connect naman. Tapos may isa pa silang gustong i-reach, yung isang state university dun mismo sa Marawi. So yun, hanggang ngayon, naghahanap pa rin kami ng paraan paano ma-connect. Pero yun yung challenges nung research network.
So, yan. Thank you for the network updates. Yes, ma'am.
Cecil D. from Isabela. May I know if you have also a designed connection to Isabela State University or the province of Isabela, because we are the rice granary. So, and we really need the connection.
Actually, before, ma'am, we had a connection with ISU through kina Sir June Dioses ata, kung di nagkakamali. Then, right now, to get actually to hubs like that, we ride on dun sa infrastructure ng DICT. So, we usually sync with DICT kung umabot na po sila dun. Then, we go to the state universities. So, nasa plano naman po, humahabol lang yung plano po ngayon.
Yeah, actually yung DOST line, it's in Kawayan itself. So yun palang gagamitin nyo din, no? Yeah, definitely. Okay.
Yes po.
It's already there. It's already there.
Sige po, siguro we proceed na kasi medyo ano na rin, naghabol tayo ng time. I'd like to, for the network, yun yung updates. Now, I'd like to call on my colleague, si Christian, to give updates naman on the HPC and the cloud resources.
Okay, so ito yung updates natin ito lang yung quick updates on COARE. So, yeah. Just a quick introduction, what is CORE? So CORE was established way back in 2014 at ASTI, and it offers 3 services: high performance computing, science cloud, and data archiving facility. So the main focus of this facility is to cater to researchers to have access to large computing and be able to share their data freely. So updates on the HPC. So we have, this is the current resources of our HPC, which is very relatively small. We have 1,104 cores and 2,208 threads for the batch computing, and 48 cores and 96 threads for debug. Total, we have 2,304 threads. So for the RAM, we have 12 terabytes worth of RAM total, and currently we have 2 GPUs, which is both 2 Tesla K80s. So in the future, near future, we are building a next HPC, next generation of this facility, which can overall have 4,576 threads and total of 26 terabytes worth of RAM. And it also has 6 GPUs, 6 Tesla P40 GPUs, and for these 6 nodes, it has 1 terabyte of RAM each. So this can be used for your high memory intensive jobs, for mostly, if I remember, genomics data that is serial in nature because it handles all its processes in a single thread, but it consumes a lot of memory. So next is the Science Cloud. So updates, we have an existing Science Cloud that has, you can access it in Core Cloud.asta.usa.gov.ph/dashboard. It is an OpenStack cluster deployment. It currently has 2,304 virtual cores, 2 terabytes of RAM, VRAM, and 450 terabytes of hard disk space. So in the near future, we are going to build a Site 2 of this, which will be in active replication of the Site 1, so that it can have geo replication and higher availability. So we are going to turn down the migration of Science Cloud V1 VMs to this platform soon. So if I remember, the project now is currently hosted in Science Cloud V1. So soon we will try to migrate it into a more stable platform. So data catalog, you can access it in asti.usa.gov.ph/core/data. We are currently trying to have more researchers publish their data in this platform. So it currently has 18 terabytes worth of data out of 255 terabytes. So we are currently trying to index the ERI 3KRG data, which is currently not here, because soon, once we have indexed the 3KRG data, it will have another 130 terabytes worth of data. So the second site, we are planning to have a second site of this data catalog, which will be hosted in RDC, our Research Data Center, behind ASTI. We will be reconfiguring it for disaster recovery purposes. So basically, all of the data in Site 2 will be replicated in Site 1 so that it will be pre-configured and be ready to have geo-replication. So just in case for disaster recovery. So we have currently 3 sites. Site 1 is in Site 2 is in the ICT, and the third site is still under construction, the third generation HPC that we are building, which is in Makati. So the main focus of these slides is actually how do we build this shared infrastructure. So after the technical updates, here's the main slides. So the current status of this institute, our country, is we have CORE, and other facilities other institutes have built their own HPC resources. So there are some. The main reason why, reason is most of the time they are not aware of CORE, so they have built their own HPC facility. So now we have the existing infrastructure to have this, and we have focused it to be designed to handle our own workloads. However, and the way I see it is, it leads to some kind of inefficiencies, because there are times that CORE is overloaded and the other institute's workload is not. So the way we're proposing is that we can have a shared HPC environment wherein I have a job, wherein say I have a workload job, and I can actually delegate it to CORE or other institutes that is part of the cluster. And also it can work vice versa. So if I say before I have 10 jobs, I can actually delegate the 6, 7, and 8, 9 jobs to other participating institutes, so that the data or the results are actually processed faster. And for disaster purposes, we need to have fast data. So we need to have fast results to get the results faster, so that it can be distributed to the LGUs. So here are the challenges in setting up this shared HPC cluster. So we need the network, the compute resources, storage, the authentication and security part, and as well as what applications are we going to run in this shared facility. So the main requirement for me is that all applications should be free and open source, so that every other institute can implement it just by using commodity hardware. So here are the solutions. So we have PREGINET. So the network is already there. So we can actually build this type of facility. We can implement what they have implemented in the European grid, in the Asian grid, in our local space. So we have, for the compute and storage, we actually have our own data centers. We manage we have in the local space, we have our own data center in UP. They have a data center in LaSalle and in Ateneo. So they have the infrastructure is already there. So the authentication, I was curious on how it was built, the film. So we can have a federated ID management system. So let's say I am from up.gov, up.edu, and I want to access some CORE servers. So if I am a student in UP, I do not need to register in CORE. I can just register in UP, and my credentials, the up.edu, the realm of up.edu, will be vouched as a trusted user to access CORE. At the same time, CORE can access UP files if permitted. So, yeah. So the application side, I'm looking at Singularity. It is a container-based for HPC applications. So this is to facilitate the applications that is going to be run in the HPC. If you are familiar with Docker, this is a Docker-like way of application. So Docker doesn't, the good thing with Singularity, that's the reason why it is not used, that is why it is being used, is because Singularity does not provide super user privileges to the user, whilst when you use Docker, it is going to provide super user privileges on a user level. So yeah, basically that's it. So want to join. So the infrastructure, the main takeaway from this is we have our own infrastructure that can be built. So the main benefit for you guys is that if we have built this, if we have built it correctly, we can have a faster way of getting results, less queuing time, and more efficient use of our resources. So thank you.
Thanks, Christian. Okay. So there, basically that's in terms of the HPC and the cloud resources that we have at ASTI. What Christian is saying, the third site, the target for that to be up is, well, hopefully December this year. Medyo matagal na din kasi yun. So we want that up in anticipation of the several activities that we are looking at, like for example yung sa CERN experiment ni UP NIP. At the same time may iba pang mga naka-line up. Okay, so with that, Christian has mentioned about having a shared infrastructure. I guess I'll go to the next presentation, which is, well, I'll be presenting it. It's really what this joint stakeholder meeting is all about. For those of you, baka hindi pa po familiar lahat, we conducted a national HPC and research computing shared resources readiness survey for the Philippines. So, sorry. Okay. So basically, I'd also like to yung idea also actually came from Doc Roel, who were collaborating with dun sa Prime project. So he said, kasi binalita namin about this stakeholder meeting, and recently parang ASTI together with Prime conducted yung or carried out yung HPCN. So he just said that, okay, if you're going to have the stakeholder meeting, what's new to tell everybody? So parang he brought up this idea that if we want to push for a shared HPC infrastructure, then why don't we have a survey for all those who are maintaining a research computing facility sa universities, and not just ASTI. Okay, so the objective of the survey is to gather relevant information sa current research HPC and research computing facilities that we have in the Philippines, either those being maintained by research institutes, by government, or universities. Actually, interested din kami dun sa private. And I guess andito pa ba si Sir Dennis ng AWS. Yun, si Sir Dennis. We met Sir Dennis just last week for a collaboration with ERI. And AWS is yung Amazon Web Services. They're private, but I guess they have extension programs or parang yung mga corporate social responsibility. And they're very much interested to help, especially yung academe, doon sa mga HPC or cloud needs ng mga universities. So I also invited him here. Okay, so yung specific objectives for this, to have an overview of the currently available research computing facilities, and with that to assess kung how ready are these facilities for us to have a national shared infrastructure. Okay. Okay, so intended respondents then, for the purpose of this survey, we know kasi in other countries, universities really maintain yung mga medyo malalaking HPC facilities. But for the Philippines, mga ano tayo, nag-start tayo sa small scale. So those respondents for this include yung mga small, medium, or yung mga large scale na core computing facility in the university. Okay. Okay. So yung design ng survey was adopted from the Enhanced Regional EU-ASEAN Dialogue Instrument, or the E-READY HPC Coordination Group Survey. So kanina pa na-mention yung dun sa ASEAN HPC Task Force. So this is, I guess, part of that initiative is merong binuong group or consultants para mag-conduct nitong survey na to dun sa mga national HPC facilities doon sa mga participating ASEAN member countries. So with this survey, si ASTI yung sumagot. So maganda yung survey, and we thought that hindi na kailangan mag-start from scratch yung national survey na gagawin. We can actually adopt it. So we asked permission from yung gumawa ng mga survey instruments if we can adopt yung survey, and then parang modify lang ng konti in the context of the Philippines, and pumayag naman sila. And actually they were very happy na may ganong initiative tayo sa Philippines, and they hope na pwede din yung i-adopt ng other ASEAN countries. So we're actually in a good direction. Okay, so yung scope, so intro lang what the survey is all about, and then yung contact and organization details, and then yun, 2 questions lang yun. Tapos yung a little bit of the profile ng HPC or Research Computing Center, about 8 questions. Yung karamihan ng questions is really centered on the technical characteristics ng HPC facility. So if you have an HPC facility, yan, medyo madugo to. Konting tiyaga po talaga yung kailangan. And then for those who also plan to set up their own HPC, if medyo buo na sa sa utak nyo, how big your HPC is going to be, it can also be captured dito. Okay. And then ano yung mga software and application domain needs, yung staff and support services, ano yung mga training na pinoprovide or ipoprovide, yung policy and governance para doon sa computing facility, and yung human resource and communication strategies. So basically these are the 9 sections of the survey. Okay. Okay, so we sent this out siguro mga medyo baka nabitin so we don't really compel everyone to submit yung pagsagot by this time. Nagbigay kami deadline parang November 8, parang ganon. So if you can tumatawa si Sir Roel. So if you can give yung response, thank you, and thank you to those who have responded. So aside from ASTI, sina Doc John Rob sa UP CSRC, and we really appreciate that because I guess sa UP CSRC talaga yung parang talagang HPC facility maituturing. And then from UPLB also, may mga individuals but we also welcome that kasi kailangan din makapture yung needs nila. From the School of Statistics, saka dun sa Department of Electrical Engineering ng UPLB. And then from Aurora State College of Technology also. So, yun. So, thank you din kay Sir Roel kasi din-disseminate niya yun sa mga prime partners. So, kaya din siguro nakakuha ng mga responses na to. Okay. So, among those respondents, dalawa yung nagme-maintain ng HPC facility. So, yun nga, ASTI and CSRC. 2 sabi ay in the pipeline, yung sa UPLB Department of Electric Engineering, tsaka yung sa Aurora State College of Technology. So that's good news. Okay. So, yan. Yung sa particularly, yung sa 3.5 and 3.6, mabuti naman po yung sagot ay yes. Kasi kung no yung sinagot, then that ends the survey, diba? And that ends the initiative. Kasi kung ayaw, wala nang ipoprogress. But thank you for saying that yes, you are interested in accessing an inter-organization HPC or research computing facility, and that yes, you would be interested in accessing an intrastate regional HPC or research computing center. So ito yung mga sa ASEAN side, sa European side. Yan. So basically, siguro padaanan ko lang yung konting highlights ng responses in terms of characteristics ng mga computing facility. Most of yung sumagot are free access to HPC resources. So even ASTI, you all know, sa ngayon, it's free access if you're using ASTI services. And then the users of the facilities have different levels of experience. Dun sa HPC, merong iba, wala talagang experience, merong iba may basic, merong iba more advanced naman, okay? And then those facilities, those with HPC facility have the basic data center requirements. So may power, may cooling, physical access, and security, mga fire mitigation, but ganon. Pero what we can look into, siguro yung next level would be focusing more on the energy efficiency management for power and cooling, ganon. But the basic data center facilities, nando naman po. And then those with HPC facility also provide yung mga large memory computing nodes and storage capacity. Okay, so for cloud computing nodes, yon, so far only ASTI is providing yung Science Cloud. Okay, and also so far only ASTI have long-term storage and data archival such as data catalog and tape, although backup storage right now is by request. Hindi namin siya officially pinapublicize na we're offering backup data. Okay, pero parang nasabi ko na ngayon, no? So yun. Anyway, it really depends on the resources. That's why we don't really right now publicize na about yung backup data storage. Okay, so those with HPC perform data transfer services over SSH. So through SSH pa din. And then those with HPC, benchmarks of computing and storage performance has not been performed. So yun yung mga, kumbaga yun yung mga hindi pa ginagawa, pero I guess it's safe to say that we are looking into, you know, in terms of improving HPC facilities and services, dyan din po tayo papunta. And especially now that we're looking at having this nationally shared HPC infrastructure. So for future expansions, procurement of more servers and consolidating resources with IT center for student access. Okay. So, yeah. So importante yan kasi as we all know, mga 5 years medyo na obsolete na yung mga servers. So yung continuous upgrade of servers, equipment, it's really important in maintaining this kind of facility. Although sa ASTI po, as old as 2008 yung mga compute nodes namin. Pero dahil medyo nagbe-breakdown na sila, yun yung inaano na namin siya as test bed, parang gano'n. Mahirap na siyang gamitan for production. So in terms of software and application domain needs, yan. So aside from ASTI, CSRC, tsaka si UPLB Electrical Engineering are using yung sa MATLAB, R, and Python. So I guess yun yung parang common for most researchers. And all the others installed sa ASTI, these are research specific. So yung mga users kasi yung nagpapa-install nito, and that's why we have it at the HPC. Yes po, we have MATLAB po. Ay, sorry. Yes. Sige po. Opo, yan, pwede. Siguro yung sa MATLAB will announce, no, yung sa access. Okay. So, ayun. So, for other applications of interest, yan po yung mga marami siya actually. But ito yung, I guess these are also, some of you may be part of this domain applications. And then physics, of course, dyan. Mostly, marami din kami on climate, mga disaster management applications running on the facility. Okay, so for staff and support services, so far yung ASTI, well, we have a full complement. Meron kami sa management, operations, R&D, and dev. We have a whole team for that. I guess it's 17. We're 17 in the group from management up to yung sa dev. And then CSRC, well, si Doc John Rob yung nag-head ngayon sa CSRC, and then he has 2 sysad, yung mga technical, right sir, na nagma-manage nung facility. So of course yung staff composition, most are university graduates and some have yung advanced degrees. Yeah. And then those with HPC facility ay may ticketing system to handle support services. Okay, so, and also those with HPC facility offer level 1 support. Dito yung definition po nung level 1 dito is, I think, yung in terms of business severity. Okay, yung dito dun sa survey, dito sa bullet na to. But for the support staff sa ASTI, yung L1 namin, yung level 1 means yung help desk. May 2 kaming tao. Level 2 is yung iakyat mo sa technical. So level 3 is higher technical. And finally, level 4 is yung sa management level. Tama, Charmaine? Okay, so si Charmaine kasi yung sa ITSM person namin. Okay, and then sa support staff for CSRC yon. So we have 2 sysad nga and then 1 management. Tinag ko lang si John Rob dito as yung sa management. Okay. And then for training, only ASTI currently offers training. So on basic HPC training lang. So ito yung mga topics typically covered is basically it's how to access yung HPC and other resources nung core. Okay. Pero yan, yung in terms of topics desired for user-oriented training, it's not our expertise. We don't have the expertise for that. But if you, as users, want to offer, for example, in terms of MATLAB or statistical computing or bioinformatics and genomics, then that's something that we can probably offer later on if we already have a nationally shared infrastructure. Is aside from yung pag-access ng HPC or basic HPC training, we'll have training on these areas as well. Okay. For policy and governance for local HPC resource sharing, so sharing of access to HPC facilities within research institutes in the Philippines is currently not in place. So wala pa po yun. Wala pa tayo niyang individual organizations. And then the incentives or barriers foreseen for HPC resource sharing across research institutions in the Philippines. So yan po, in terms of incentives, yung mga sinagot, share data sets and programs that can be used by most or all institutions. So data sharing. So if there are research data that can be used by different research groups, then okay yun. That's also what we are advocating at ASTI. Okay. So pooled computing resources shared among research institution means access to greater computing power and storage resources. So that's an incentive for having a shared infrastructure. In terms of barriers, well, of course, andyan yung internet access and speed. But if we are connected to PREGINET, I guess baka medyo hindi masyadong issue yon. Okay. And then technological know-how is also shallow and lacking in most institutions. So basically, kasi siguro po yung mga gantong klaseng facilities is relatively new, mga ilang years pa lang. So yung capability po siguro dito is still currently being built up. Okay. So sa ASTI, hindi rin naman po naging madali yun. Until now, we're also still, building yung capacity for running a national HPC infrastructure. Okay, and then readiness and willingness to provide access. So it's always an issue if the institute is, or the university is not open to share data, probably because of security issues, kung may security issues. So yun, and I guess that's why we invited you sa Science DMC. In our experience, I guess the main issue we have encountered is always between the network people and the research people. So sa ASTI, ang ina-advocate namin, how do we really bridge yung gaps between the network people and the research people? And for the network part, to facilitate yung ginagawa po natin sa research. Okay. So anyway, infrastructure limitations also can be a barrier. Okay, so sa human resource naman, in terms of gender breakdown, of course, still mostly male, although sa ASTI more or less may 50-50 kami male-female, pero it's both technical and non-technical. Okay. Academic or public discussion or press coverage on the importance of HPCUs for research and innovation is not yet sufficient. And then yung sa suggestion, what communication strategies would be effective in raising awareness on the importance of the development of HPC with key policy and decision makers within the government. So yon, mga seminars and workshops for different levels of involvement and target groups, promotional events, press coverage, may DOS TV po. So we can increase those kinds of activities and possibly yung mga gantong klaseng venues or conferences. Okay, so suggestions on medium or long-term activities that might generate academic or public discussion on the importance of HPCUs for research and innovation locally. So like I said, mga HPC-related conferences, both local and international. For the long term, maybe a dedicated team can be in place from the national level. Okay. And I guess right now, default po si ASTI, since ASTI stands as a sort of a national HPC infrastructure. Okay, with the help, of course, of other groups na meron ding experience sa network or sa HPC. Like for example, kanina pa na-mention ni Bani si Bert. Bert is also part of COARE. But right now he's on study leave, so he's with a team of Doc Roel, but he's still working on yung sa network, ganyan. So those things, and then collaboration with other institutions. Okay. So yeah, so moving forward, this is the last slide. You may still answer the survey, and then you may share it with others as well. Pwede ko pong i-provide uli yung link for this, and then we can set the deadline by November 29, in time for us to have a consolidated report by year end. And then we can share this consolidated report with the group, with you, siguro kay Sir Dennis then. I guess it will also feed into yung sa ginagawa nila for the National ICT Assets Index. And then I'm thinking, this is not something that ASTI alone can do. Parang kung wala naman kaming collaborators, how do we really proceed with this initiative na mag-set up ng isang national or locally shared HPC infrastructure? So we really need siguro volunteers or those na magla-lobby together with ASTI for this. So I'm looking at Doc Roel. Si Doc Roel siguro yung parang I guess because naramdaman ko naman yung ni Doc Roel doon sa initiative. Actually, sa kanya ko una narinig yung federated HPC and yun. So I guess if anyone else is interested, especially those na merong HPC infrastructure and may plano to have an HPC infrastructure, we really need, I guess, to set up maybe a technical working group. We can start a technical working group para mag-progress po ito. Okay. So kung okay po kayo doon. Okay. So, yun lang po. Doc Joel mentioned earlier about a CNIVO forum to be held next week at the Crimson Hotel in Alabang. And there is a poster presentation for the science infrastructure at ASTI. And ito yung topic na binigay namin, setting up a locally shared infrastructure for more resilient network, compute, and storage resources for research. So we really want to push this initiative, and hopefully with the help of this community. That's why it's a joint network and HPC community. First time namin ginawa. Hopefully this will start, or this will ignite further discussions. Tsaka yun, we really need to work together to be able to set this up if we want to set this up. Okay, kasi kung si Aste lang, wala. Di rin siya mangyayari, diba? So we really need your help. We're always emphasizing sa mga venues like this yung importance of collaboration, and that's also what Sir Dennis earlier said. Doon sa pag-build ng network, sa pag-build nung infrastructure sa ASTI, it's not just ASTI. It was really a matter of collaboration. Lapit talaga sa mga makakatulong. Okay, so that's what we are advocating until now. Okay, so I guess that ends my my presentation. Anong oras na? So 12:35. Actually, dapat yung 11:30 to 12:30 merong parang open discussion. If anyone still wants to say something, maybe maybe a show of support, or if you're willing to help, pwede po kayong magsalita. Or if you want to share any I guess experience. Yes, Dr. Roel.
I am guilty of not answering the survey yet.
Okay lang, sir, may chance
I'm
pa.
so sorry. But just to add to that data off the top of my head, of course, Prime is very much interested to set up a facility that would be shared nationwide. From our travels so far, meetings so far, there seems to be interest as well in UP Baguio, CLSU definitely, UPLB even in computer science,
MSU IIT.
MSU IIT, very strong interest, Caraga State, I think. So among a few, no, and even in the there have been some discussions even in the College of Engineering here in Diliman. So that's one. We'll try to encourage them to answer the survey as well.
Okay,
Para
thank you, sir.
kasabay naman kaming late mag-answer ng survey. Tapos on the matter of getting this started, siguro I would like to issue a friendly challenge to ASTI. If you have resources internally or through the UST to expand COARE, maybe you could really start and proceed in this manner. So parang instead of building it largely internally, physically, inside ASTI facilities, start building it na rin in a distributed way. Maybe distribute starter kits dun sa remote sites. So get people together, train them na workshop, tapos iuwi nila yung kung ilang starter machines, no? Ang commitment ko naman on my part is I'll also try to write the usual proposals then, no promises as you know, para madagdagan din yung resources na yon. In fact, ang target namin is this week or next week we'll try to put in a proposal sa CHED para mag-develop din ng parang HPC starter kits din sa ilang SUCs. So, you know, we could pool all of these resources together, as is the theme of this gathering, and, you know, come up with something substantial for the entire country.
Yeah. Thank you, sir. Abangan namin yun. And I guess there are other external sources of funding that we can tap. Aware din ako, sir, no, sa Asia Connect, you also have a project, right, on sa Asia Connect. So, yun. So yes, I guess we're not limited to DOST funding. We can tap other sources of funding. Pero magandang idea yun, sir. Support kami doon sa idea na yun ng HPC starter kit. Okay. Yes, sir.
Second na rin kasi yung sinabi ni sir, I think it will be very important if you're going to want to do it distributedly. Sana yun nga, I hope that if within the resources permit, that COARE can help assist yung mga nagbubuo ng nodes. Experience kasi namin doon sa laboratory namin sa electrochemical engineering dyan sa ChemEng. Ang nangyari sa amin, we pulled our research money, mga estudyante kami, and we bought nodes. Ngayon, hindi namin alam kung anong gagawin namin sa kanila. So, I think if there is such a thing as yung parang starter kit or at least a starting training kung paano siya i-configure, I think that would be very helpful. Kasi mahirap naman yung 4 lang kami estudyante tumitira nito.
Okay. Sige, sir. So, magandang opportunity for us yung manalalaman namin yung mga ganito na may ganon pala. Kasi I guess, even si COARE, hindi naman ganon kakilala pa ng, you know, the research community. Yes, sir.
Good afternoon. Magko-comment lang ako just to one support but at the same time give caution dun sa suggestion na yun. So support, I think that idea really makes sense, so that we can expand the pool of people that can support this work. So deploy para starter kits or encourage groups to build their own clusters and see how it can be federated. And then caution that maybe, you know, we should look into yung idea of creating a distributed HPC in a limited manner, in the sense that we want this to be an operational platform that we can maintain a certain level of service availability and performance. So not too distributed na every institution has their own, they think that, you know, they can share it for actual research work. So, you know, siguro a few to be able to ensure high availability and resiliency, kasi alam mo naman Pilipinas subject to, you know, a lot of these hazards. But then not so many na, you know, it will be difficult to maintain, operate. Kasi that has to be up 24/7. You need operational support, so persons. What I think we really need would be people who can use this infrastructure and help the yung science, no? So scientists and researchers we need to bridge the gap between our existing scientists and engineers who are used to yung methodologies, but then we have new techniques available, more computationally intensive or yung ganon. And we need to bridge that gap. So we need more people who understand and know how to use this to be able to deliver good science nga. So, yeah.
Thank you, sir, dun sa input. Yeah. Actually, like even yung sa Europe na mga e-infrastructures nila, we participated before dun sa EU Asia Grid. So we don't really share all of our resources. You just parang meron lang kaming may ipo-provision lang kami na ito yung resources that we will share to that shared infrastructure. So that can be a model. So it doesn't mean na we share all of our all of our resources sa HPC facility. Okay. Yes, sir.
Hello, good afternoon. Brian Rafor po from the UP Diliman School of Statistics. First, magte-thank you lang ako. HPC has been very helpful dun sa research na ginagawa ko. And then, one question and one suggestion. Yung question po is, are you thinking of putting parang live chat in place for the HPC? I understand na mas maganda pag documented siya via ticketing service, pero might be very helpful to get quick wins. Lalo na, for example, kung ang question ko lang is about a specific technical point on HPC, tapos mabilis sana yung turnaround. Okay. And then the second one, yung suggestion ko, I think at least kami sa stat, most of them medyo afraid of HPC kasi parang, of course, you have to learn a lot of things, Linux, Slurm, and whatnot. They're very good in terms of statistical sciences, pero hindi ganun ka-adept in terms of computing. For example, I myself, nagkataon lang na may background ako sa IT kasi yun yung undergrad ko. And then, so parang being code savvy, na-enjoy ko siya, pero transferring that to other stat people, medyo may gap. So what I'm thinking, maybe it would help ASTI kung magkakaroon tayo siguro ng local champions. For example, our applications for statistics, we can man that specific discipline para mas madali, mas ma-encourage namin siya. Actually, sa Monday, magkakaroon ng our workshop, ako yung magde-deliver. Tas parang yung point of view ko na sa kanila is, yung code mo, dapat hindi mo iniisip na magra-run lang sa PC mo kasi pwede mo siyang i-deploy sa HPC and then therefore making it very efficient in terms of runtime. So, siguro yun lang po.
Sige. Sir, doon sa una, yung sa live chat, noted. Siguro we'll look into it doon sa help desk kung how we can implement that. Yeah, and then yung dun sa second, yes, I agree, and we can plan for that. And I guess that's why yun din yung part na yung sa training na yung para hindi lang siya yung HPC per se, how to access the HPC, pero yung naka-focus talaga dun sa yung mga domain application. So noted din dun sa second suggestion, sir.
Sorry, nag-reply na ako dun sa survey pero hindi ko nakita yung UPD School of Statistics.
Actually, baka after
yung LB.
Baka. So, so sorry. Hindi pala yung UPLB, pero i-correct ko na lang, sir. Yes.
Hi, good afternoon na pala. Dennis Magsaho po from Amazon Web Services. So, firstly, thank you po for inviting us in here. Ang objective ko po sana is to get a better picture of the research community in the Philippines and then hopefully find ways to sort of assist, right? So, I guess in some of the questions, like for example, a lot of the discussions were on network, compute, right? Yung sa, ang case ko po kasi I'm trying to see how I can fit the commercial cloud into research applications, because in our case, we just spin up the resources without worrying too much on the networks, because presumably the cloud takes care of that one, right? So of course, yung cluster na lalabas may not be as you would expect, but like for example, yung question on like students who would want to start immediately with HPC, right? So without trying to understand the nitty-gritty of the network, the servers, the cluster, we're looking into ways na, halimbawa, a facility, ay nakita ko yung shared HPC model where you have different locations, diba? So parang ang unang na-imagine ko, what if there's one portion where it's actually in AWS or a cloud provider. It could be Google or Azure. But you will have access to that para mas mabilis mag-spin up ng cluster. And then you can go straight if you're using Slurm, Torque, or SGD. Parang mas may naskipan kayong processes. Like if you're looking into going into the HPC software diretso without worrying, katulad nun parang may bumili ng servers, di ba? And also, we're looking into transient clusters. Kasi di ba, parang may mga cases na you buy a cluster for a particular workload, you run it once, pero probably you won't be running it on a daily basis. Right? It's a bit costly, especially for students. So sige, bubuo ako ng cluster ko, pwede bang may mahiram muna? So the shared HPC model is actually, well, it's an excellent idea. Right? So again, on our case, as you've mentioned earlier, we have research programs where we can probably subsidize some of the costs. Like, for example, if you're doing research, we have programs for research and we can provide cloud credits for that one. So I would want to put it on the table that AWS is willing to sort of assist on that manner. And to Sir Ruel, thank you po, pinasamo ko sa EE9. So, kung di dahil sa inyo, hindi ako gumraduate. Yun lang po.
Thank you, Sir Dennis. Nagulat si Doc Roel. Pero yeah, it's good to hear on the AWS side. And I know there are a lot of opportunities for us to work with the private provider like AWS. Magkikita pa naman tayo, sir. May mukhang marami tayong collaboration. So, yeah. Okay. Sige po. Anything? Ay, sige, si Sir BA.
Hi, BA Racoma. Previously from UP NOAA, pero ngayon, I'm part of the Institute of Environmental Science and Meteorology. And gusto ko lang din i-echo yung na-mention ni Sir tsaka ni Sir na how to bridge the gap between researchers who want to use the resources versus yung, kasi sa IESM, nagre-range yung researchers namin from zero computer knowledge to very advanced. And as mentioned nga kanina, isa sa mga uses na HPC is weather modeling and climate modeling. Pero right now, I don't think may gumagamit from us.
Dati si Jaya.
Dati si Jaya, wala na si Jaya ngayon. Maganda sana kung may bootcamp for researchers na na gustong matuto sana. Kasi for example, kami ng email na gusto namin makipag-usap sa inyo, pero yung mga researchers kasi natatakot. Kasi usually when they program in Python and in MATLAB, gusto nilang interactive. When they run, nakikita nila kaagad. Rather than they submit sa Slurm, they wait for the results, paano kung mali pala? Especially ang climate models takes weeks to run. So, meron bang interactive mode, meron bang bootcamp na para lang ma-jumpstart yung yung mga from zero knowledge to high-level knowledge.
So, noted namin. If ever, siguro, usap tayo. Okay. So, anything else? Ay, yeah, si Doc John Rob.
John Rob po from CSRC. I think familiar naman siguro kayo, kaka-mention na kayo ni Jen na CSRC is trying to come up with a much better HPC facility. And I think yung lack sa amin is technical know-how, and we wanted to learn from those who have already experienced setting it up and maintaining it so that we can go at par with what you have already achieved. That's the first. The second one is perhaps you can also give some, yun nga, related doon, bootcamp, related for experts for the technical know-how naman yun. Kasi even for other campuses like IIT, I heard they also wanted to create HPC level. Maganda po na magbigay kayo ng training for the technical aspect of it. Ano yung mga network requirement, ano yung dapat na tatagpigtigpiin ng mga equipment. And then, the other one is, I forgot. Maganda po na magkaroon ng policy which is fairly uniform. I think this is for Sir Villorente para mas maganda po na magbigay ng nationwide siguro na level for those who wanted to set up their HPC, magkaroon po tayo ng common protocol. So that hindi nag-iiba-iba at madaling mag-connect. So that security and all that, mapaplansya agad natin from the beginning pa lang. So that yung mga specs natin ng network, switches, dapat compatible na sila lahat. Even the protocols that we wanted to install. Kasi minsan pipili ka from open source to, kung halimbawa minsan may mga companies or units na they wanted proprietary, lagot na tayo lahat. So kung makaset up na agad tayo ng minimum requirement for easy interconnection, that would be best also. Thank you very much.
Yeah, thank you, Doc John Rob. Yes, nakikita ko yon can be part of yung itong initiative. Starting siya nung initiative na to. So we'll take note of that. Okay, so anything else? Yes, Ma'am Amor.
Added note lang din po, please consider dun sa starter kit, that this is nice. Siguro maging output-driven na in a way na yung contribution makikita ng government para maging mas aware sila sa relevance ng impact ng computing sa Pilipinas. Kasi nasa initial stage pa lang tayo eh. So funding is quite important in HPC. Yun po yung main challenge natin. Thank you.
Thank you, Doc Amor. Anything else? Parang baka nagugutom na po tayo. 12:15. Okay. So, kung wala na po, this is not the end. Kumbaga yung event lang yung nag-e-end, pero it's actually the start of what lies ahead in terms of more collaboration. And yung dito po, definitely ko-contact po kami, lalo na dun sa mga magsasagot sa survey. Sana po makasagot pa kayo dun sa survey. Yun. And then those who are interested to sir, kasama din po. So actually that CEO in Lasal. We also invited yung sa DLSU Manila. Unfortunately, hindi sila nakapunta, but I guess DLSU is also planning to set up a facility. So yun yung mga inaano din namin, mga interested kami dun sa mga ganong information. Okay. So yes, ma'am.
I am Neng Juliano Tamano. I am the national chairperson of the Federation of International Cable TV and Telecommunication Association of the Philippines, and we have 800 members from Batanes to Jolo. Now, I would like to ask if this project of yours is applicable nationwide in all areas that has state universities or state colleges.
Yes, ma'am. Parang in principle, yes. Because yung mga iba, like for example, si Ma'am Amor is from CLSU, and then we have yung sa MSU, IIT, and then from other state universities and colleges regions then yung dun sa yung sa prime project ni Doc Ruel. So it's not just yung sa Manila, pero it's region-wide, it's nationwide.
So it is
hopefully.
Is it also applicable in BARM areas? Because I operate in Maguindanao, in BARM areas. Bangsamoro Autonomous Region, Muslim Mindanao.
Yes, ma'am. Actually, we're yung laying the network doon sa Marawi and sa meron din. Nationwide naman po yung coverage ng network. So as long as we have coverage doon sa PREGINET coverage doon, that's something na we can reach.
Yeah, because UNDP partnered with FICTAP to deliver internet in all the schools in the Bangsamoro, Muslim Mindanao, and also to all barangay halls in BARM area. That's why I want to know if it is included, that part, because we will be installing connectivity in those areas.
Sige, ma'am. Ano naman, we'll contact you to...
I think, Ma'am Neng, if there is a scientist or a researcher that's interested in a state U, then that's the time that we move to try to bring in the resources. Kasi medyo niche yung applications nitong infrastructure na to. For example, what exactly are you doing sa HPC? Weather modeling, genomics, bioinformatics. So kung may faculty po na ganun dun sa state U na interested, gustong sumali, they're more than welcome. Then we can try to mobilize funds to connect that state U po.
Okay po. So, wala na. Sige. So, I guess, ako na lang din magko-close. We again would like to thank you for joining us in this first joint PREGINET and COARE stakeholders meeting. This is just the first. Hopefully, sige, tignan natin kung meron pa next year. Hindi, meron pa next year.